Hello everyone, welcome back to Maths Marathon classes. In this session, I'll take up differentiation, NCERT miscellaneous exercise. Okay, so we'll take up one by one all the problems of miscellaneous exercise. Hope you learned all the differentiation formulas thoroughly. The various methods of differentiation we learned, that is chain rule, derivatives of composite function, implicit function differentiation, then derivatives of inverse trigonometric functions, logarithmic differentiation, parametric differentiation, second order derivatives, then also how to differentiate determinant. All those things, concepts, different concepts we learned, all the problems we're going to discuss in this session. Okay, one by one. The first one, that is miscellaneous exercise on chapter 5, continuity and differentiability of second PUC. That is, does there exist a function which is continuous everywhere but not differentiable at exactly 2 points? Justify your answer. So they are asking to find a function, if there exists a function which is continuous everywhere but not differentiable at exactly 2 points. We know f of x equal to mod x, a familiar example. F of x equal to mod x is continuous everywhere but it is not differentiable at x equal to 0, right? That is not differentiable at exactly 1 point. Mod x is not differentiable at exactly 1 point, that is x equal to 0. Like that, we can have many other examples. Not only mod x at x equal to 0. If you take mod x minus 1, it is not differentiable at x equal to 1. Correct? F of x equal to mod x minus 2, it's not differentiable at x equal to 2. Like that, we got many examples where the function is continuous everywhere, which is not differentiable at exactly 1 point. Now they are asking to tell or give an example for a function which is not differentiable at exactly 2 points. So I can construct a function of this type. I'll take f of x equal to mod x plus mod x minus 1. Modulus function is continuous everywhere, we know that, correct? So modulus function is continuous everywhere, and if you take mod x plus mod x minus 1, it is also continuous everywhere, but it is not differentiable at exactly 2 points. Okay, so we'll take this example, f of x equal to f of x equal to mod x plus mod x minus 1, or else I can take mod x plus mod x minus 2, or I can take mod x minus 1 plus mod x minus 2. All will do. Okay, sum of two modulus function. Okay, sum of two modulus function. Inside the modulus you take a linear term, better. Okay, or else I can take f of x equal to mod x square minus 1. That is also not differentiable at exactly 2 points. Mod x square minus 1. I can write many examples for this. Okay, one example I'll take first and explain in detail and write many more examples for this. Okay, f of x equal to mod x plus mod x minus 1. Here the critical points are where terms inside the mod now become 0. Such points are called as critical point. Critical point for this is x equal to 0. Critical point for this is x equal to 1. Correct? So 0 and 1 are the critical points. So if you take a number line and represent 0 and 1 here. 0 and 1. So I'll divide this into 3 cases. X less than 0, x greater than or equal to less than 1, and x greater than or equal to 1. We'll redefine this function for 3 cases. One is x less than 0, left side of 0, minus infinity to 0, and 0 to 1, including 0, excluding 1, and x greater than or equal to 1. So we can rewrite this function f of x equal to if the first case is for x less than 0. Next case is for x between 0 and 1. 0 less than or equal to x less than 1. This is for x greater than or equal to 1. Okay. For x less than 0, if you take a number which is less than 0, say x equal to minus 1, x is minus 1 is negative. When you put x equal to minus 1, minus 1, minus 1, minus 2, negative. So when x is less than 0, mod x becomes minus x. Mod x minus 1 becomes minus of x minus 1. Correct? You can redefine this function as minus x minus of x minus 1. Correct? Mod x is minus x for x less than 0. Because x is negative. When x is negative, even x minus 1 is negative. Put x equal to minus 1. So minus 1 minus 1 minus 2. So mod x minus 1 is minus of x minus 1. For x between 0 and 1, take a value greater than 0, less than 1. Say you take x equal to 0.5. When you put x equal to 0.5, x is positive. When x is 0.5, 0.5 minus 1 is negative. Correct? For x between 0 and 1, including 0, excluding 1, mod x will be x. Mod x will be x. And mod x minus 1 is minus of x minus 1. And for x greater than or equal to 1, mod x becomes x. Mod x becomes x. And mod x minus 1 is x minus 1. Correct? For x greater than or equal to 1. We have like this. I am dividing like this. So I can simplify this function further. Minus x minus 2x plus 1. Therefore my function f of x becomes, my function f of x is equal to, what we get, minus x minus 2x plus 1. Correct? This is for x less than 0. This is for x less than 0. Second case, x minus x 0, minus of minus 1 becomes plus 1. This is for x x between 0 and 1, right? X between 0 and 1. X between 0 and 1, including 0, excluding 1. And last case we have 2x minus 1. 2x minus 1. This is for x greater than or equal to 1. So, if you're discussing the continuity of this function, definitely it is continuous everywhere. How to explain? For x less than 0, f of x is minus 2x plus 1. Being a polynomial function of degree 1, it is continuous everywhere. We know that polynomial function is continuous everywhere. For x between 0 and 1, including 0, excluding 1, f of x equal to 1, being a constant function, is continuous everywhere. For x greater than 1, f of x is 2x minus 1, being a polynomial function, is continuous everywhere. The doubtful points are at 0 and 1. So at x equal to 0, find out the left hand limit, right hand limit and the function value. At x equal to 1 also, find out the left hand limit, right hand limit and the function value. Okay. At x equal to 0, all the explanation sentence I won't write here, just explain orally. If you can write all those things. At x equal to 0, okay, you want to find the continuity of this function, that is left hand limit. Limit x tends to 0 minus f of x. Limit x tends to 0 minus f of x. 0 minus means x less than 0. X less than 0 means minus 2 into 0. 0 plus 1, 1. Correct? Limit x tends to 0 plus. Limit x tends to 0 plus f of x. That is right hand limit at x equal to 0. 0 plus means x greater than 0. X greater than 0, function value is 1. And at x equal to 0, the function value is 1. All are equal. See, the function is continuous. Left hand limit equal to right hand limit equal to function value. This is left hand limit. This is right hand limit. This is function value. So left hand limit equal to right hand limit equal to function value. Therefore, the function is continuous at x equal to 0. At x equal to 0. And at x equal to 1 also we can find the continuity of the function at x equal to 1. At x equal to 1, what happens? Left hand limit you find out. Limit x tends to 1 minus. Limit x tends to 1 minus f of x. 1 minus means x is less than 1. X less than 1, the function is 1. So limit of 1 is 1 only. Right hand limit. Limit x tends to 1 plus. Limit x tends to 1 plus f of x. Limit x tends to 1 plus of the function f of x. F of x is for x greater than 1. X greater than 1, I have to use this. 2 into 1, 2 minus 1, 1. 2 into 1 minus 1. That is 1 itself. I wrote directly here, okay. Otherwise I have to write all the steps. Limit x tends to 1 plus actually. Actually I have to write the steps. Still directly wrote limit x tends to 1 plus of 2x minus 1. Then if you want, I'll write the steps here. How to write? This is equal to limit x tends to 1 plus of the function is what? 2x minus 1. Put x equal to 1. 2 into 1, 2. 2 minus 1 is 1. So right hand limit is 1. Even the function value is 1. Correct? At x equal to 1, f of 1 is 1 itself. 2 into 1. 2 into 1 minus 1, 2 minus 1, 1. So left hand limit equal to right hand limit equal to function value. Function is continuous at 1. Therefore, the function is continuous everywhere. For less than 0, it is continuous. For between 0 and 1, it is continuous. For x greater than 1, it is continuous. Even at 0, it is continuous. At 0, I proved left hand limit equal to right hand limit equal to function value. Even at 1, it is continuous. Left hand limit equal to right hand limit equal to function value. So function is continuous everywhere. So differentiability if we are discussing f dash of x. So f dash of x we can find out from this. This method of finding derivative is applicable only when the function is continuous. If the function is continuous, you can adopt this method. So to find f dash of x, I'll write here f dash of x. F dash of x I'll write here. F dash of x. F dash of x is derivative of minus 2x is minus 2. This is for x less than 0. Derivative of 1 is 0, correct? This is for 0 less than or equal to x less than 1. And derivative of 2x minus 1 is 2. This is for x greater than or equal to 1. See, at 0 and 1, the function is not differentiable. F dash of 0 minus, if I note. F dash of 0 minus. F dash of 0 minus means for x less than 0. Left hand derivative is minus 2. F dash of 0 plus. F dash of 0 plus is for x greater than 0. That is 0. So left hand derivative is not equal to right hand derivative. Function is not differentiable at x equal to 0. F dash of 0 minus is not equal to f dash of 0 plus. F is not differentiable at x equal to 0. And f dash of 1 minus, I'll write here, f dash of 1 minus. F dash of 1 minus means for x less than 1, derivative is 0. F dash of 1 plus, f dash of 1 plus for x greater than 1, derivative is 2. Correct? Again, f dash of 1 minus is not equal to f dash of 1 plus. Function is not differentiable at 1. Function is not differentiable at 0. So I can find a function of this type. F of x equal to mod x plus mod x minus 1. Which is continuous everywhere, but it is not differentiable at exactly 2 points. One is at x equal to 0, another at x equal to 1. They can ask it as a MCQ also. You have to learn every NCERT words, because NCERT book, every line you should word to word you should read at least and understand, because they can ask MCQs, correct? They can from each and every corner, from any corner they can ask MCQ questions. So you should be prepared. So mod x plus mod x minus 1 is a function which is continuous everywhere but not differentiable at exactly 2 points. Please learn this. I can write many examples of this type. Many examples we can write of this. So not only mod x plus mod x minus 1, I can write mod x minus 1 plus mod x minus 2, or mod x plus 1 plus mod x minus 1, or mod x plus 5 plus mod x plus 10. Like that. We can write many examples. And the graph of this is quite interesting. So this function we got simplified and we got like this. We can draw the graph. See, for x between 0 and 1, including 0, excluding 1, the function is constant. F of x equal to 1 is a constant function. Graph of constant function is a horizontal line which is parallel to x-axis. So we get a constant function. And minus 2x plus 1 is a straight line, y equal to mx plus c4. Even this is a straight line. So we get a bucket shaped graph. So graph will like this. F of x equal to 1 is a horizontal line. For x between 0 and 1, it is f of x equal to 1. And the graph for x less than 0 is minus 2x plus 1. Almost an open bucket I can call. It's a bucket shaped graph. So it's quite interesting. I'll draw the graph of this. I'll add one slide here. So f of x we got f of x equal to mod x. You can write many examples. F of x equal to mod x plus mod x minus 1. It is continuous everywhere. Is continuous everywhere. I'll write a few examples here. Continuous everywhere but not differentiable at exactly 2 points. But not differentiable at x equal to 0 and 1, but not differentiable at x equal to 0 and x equal to 1. Not differentiable at x equal to 0 and is also not differentiable at x equal to 1. If you take f of x equal to say mod x minus 1 plus mod x plus 1, it is continuous everywhere. It is not differentiable at x equal to 1 and minus 1. Correct? This function is continuous everywhere. Even this function is continuous everywhere, means continuous for all real numbers. Continuous everywhere means it is continuous for every real number, but not differentiable at x equal to 1 and minus 1. Not differentiable at x equal to 1 and x equal to minus 1. Not differentiable at x equal to 1 and also it is not differentiable at x equal to minus 1. Like that you can write many examples. Okay, more examples you want, I'll write here. F of x equal to say mod x plus 2 plus mod x plus 3. This function is continuous everywhere. Not differentiable at x equal to minus 2. Not differentiable at x equal to minus 3. Like that. In general, I can tell f of x equal to mod x minus a plus mod x minus b is not differentiable at exactly 2 points for a not equal to b. For a not equal to b, this function is not differentiable at exactly 2 points. Not differentiable at x equal to a, not differentiable at x equal to b. Hope you understand. So general form of a function which is continuous everywhere but not differentiable at exactly 2 points is this. Mod x minus a plus mod x minus b, where a not equal to b. Understood? So I'll draw the graph of this as we had here in the previous. I wrote this function here, concentrating on this. I'll draw the graph of this mod x plus mod x minus 1. Already gave the name as a bucket shaped graph. Correct? For x between 0 and 1, f of x is 1, right? F of x is 1. So I'll draw the graph like this. 0 is here, 1 is here. Correct? Here on y-axis I'll mark 1. This is y-axis. This is x-axis. I need to draw for x between 0 and 1. The function is f of x equal to 1. Including 0. At 0 it is 1. Correct? At x equal to 0. At x equal to 0 function value is 1. For x greater than or equal to 1. The function value is 2x minus 1. Correct? So the function is 2x minus 1 for x greater than or equal to 1. Greater than or equal to 1. For x greater than or equal to 1, f of x is 2x minus 1. So you can take, if you take x and f of x, I make a column like this. For x equal to 1, it is 1. For x equal to 2, 2 into 2, 4. 4 minus 1, 3. For x equal to 3, 2 into 3, 6 minus 1, 5. So at x equal to 1, y is 1. X equal to 2, y is 3. Correct? Somewhere here. X equal to 3, it is 5. So graph is going up like this. Linear function. Something like this. And for x less than 0, function is minus 2x plus 1. Correct? For x less than 0. For x less than 0, what is my function? F of x equal to minus 2x plus 1. Minus 2x plus 1. So you take negative values. Say x and f of x. I'll do the table for this. When you take x equal to minus 1, minus 2 into minus 1, plus 2, 2 plus 1, 3. For x equal to minus 2, minus 2 into minus 2, 4, 4 plus 1, 5. When x is minus 3, minus 2 into minus 3, 6, 6 plus 1, 7. So when x is minus 1, y value is 3. Correct? When x is 1, it was 1, no? When x is minus 1, the function value is going to be equal to 3 somewhere here. At x equal to minus 1, the function value is 3. 3 somewhere here. At x equal to minus 2, the function value is 5. Correct? Like this it goes up. The graph is coming like this. Like this, it extends. A rough sketch. Okay? For x equal to minus 3, it is 7. Minus 2 into minus 3. Correct? No? Minus 2x plus 1. For x less than 0, we got. Minus x, minus 2x plus 1. That is 2x minus 1. Correct? No? 2x minus 1. There we got minus 2x plus 1. So, minus of minus. Minus of minus. When x is minus 1, minus 2 into minus 1. Plus 2, 2 plus 1, 3. For minus 2, 4 plus 1, 5. Minus 3 is 6 plus 1, 7. Like that goes on. 3, 5, 7 goes on like that. So, this is a graph. A bucket shaped graph I can call. Okay. So, learn this. Important. So, this much of explanation I gave. Finally, I can conclude that this is most important. The function of this type is continuous everywhere and it is not differentiable at exactly 2 points for a not equal to b. Mod x minus a plus mod x minus b. Move on to the next one. Questions on composite function, derivatives of composite function, chain rule we call derivatives of composite function. There are some questions in the miscellaneous exercise of NCERT book, can be asked for MCQ also. So take the given function as y. Let y be equal to this. Let y be equal to 3x square minus 9x plus 5. 3x square minus 9x plus 5 whole to the power 9. This implies dy by dx equal to, it is of the type x power n. Derivative of x power n we know, n into x power n minus 1. Derivative of x power 9 is what? 9 into x power 8. Likewise, you differentiate. Differentiate this as you differentiate x power 9. Derivative of x power 9 is 9x power 8. So further differentiate terms inside the bracket after that. So what are you going to get? 9 into 3x square minus 9x plus 5 whole to the power 8 into further differentiate terms inside the bracket. Derivative of 3x square is 6x. Derivative of 9x is 9. Derivative of 5 is 0. Understood? Differentiate as a differentiate x power 9. Derivative of x power 9 is 9x power 8. But this is not x. So for the differentiate terms inside the bracket. Derivative of 3x square, 3 into 2x, 6x. Constant into variable. Constant keep as it is. Differentiate x square, 2x, 3 into 2x, 6x. Derivative of 9x, 9. Derivative of 5, 0. If you only can take 3 common here from this. If you take 3 common, no, 3 comes out. 9 3s are 27. 27 into 3x square minus 9x plus 5 whole to the power 8. What is left out inside the bracket after taking 3 common? 3 is taken outside. 9 3s are 27. So what is left is 2x minus 3. Correct? 2x minus 3 is left. After taking 9 outside, what is left is 2x minus 3. So finding the derivative of the function with respect to x. Take the given function as y, differentiate using chain rule. Derivative of composite function. There are many more questions on derivative of composite function. Take up one by one. Differentiate sine cube x plus cos power 6x with respect to x. Take the given function as y. Let y be equal to this. Let y be equal to sine cube x plus cos to the power 6x. Let y is equal to sine cube x plus cos to the power 6x. Sine cube x means it is sine x the whole cube. Correct? Sine x the whole cube. Cos power 6x means it is cos x whole to the power 6. Correct? Differentiate with respect to x. Can write a sentence that differentiate with respect to x on both sides. Differentiate with respect to x on both sides. You get dy by dx equal to derivative of sin x the whole cube. It is of the type x cube. What is derivative of x cube? Derivative of x cube is 3x square. Differentiate as you differentiate x cube. Derivative of x cube is 3x square. So derivative of sin x the whole cube is 3 sin square x into derivative of sin x cos x. So what you get is 3 sin square x. 3 sin x the whole square into derivative of sin x is cos x plus derivative of cos x power 6. Differentiate this as you differentiate x power 6. Derivative of x power 6 is 6x power 5. Likewise differentiate 6 into cos x to the power 5 into further differentiate cos x which is minus sin x. Correct? By chain rule it follows. So derivative of x power 6, 6x power 5. But this is not x. So further differentiate derivative of cos x minus sin x. So what I am going to get is 3 sin square x into cos x. 3 sin square x into cos x plus into minus is minus 6 cos power 5x into sin x. Derivative of x cube 3x square 3 sin square x into further differentiate sin x. Derivative of sin x cos x. Derivative of cos x power 6 is 6 cos x power 5 into further differentiate cos x we get minus sin x. Hope I understand. If you want, you can take common terms and simplify, or you can stop at this stage. Doesn't matter. You don't lose any marks. Understood, right? Can we move on to the next one? Given differentiate sin inverse of x root x for x between 0 and 1. In the NCERT book, they included the endpoints. I shall not include the endpoints because the function is not going to be differentiable if you include the endpoints. Okay, so I excluded the endpoints and made a correction for some of the questions. So I'll take this as y. Let y be equal to sin inverse of x root x. Y is equal to sin inverse of x root x. Of course, x root x could be written as x power 3 by 2, right? Sin inverse of x root x. X means x power 1. Root x means x power half. Correct? Bases are same. Because of multiplication, we can add the powers. 1 plus half is 1 and a half. 3 by 2 it becomes. This becomes sin inverse of x power 3 by 2. x power 1 plus half. 1 plus half is 1 and a half, 3 by 2. Now we differentiate with respect to x on both sides. Differentiate with respect to x on both sides. We know derivative of sin inverse of x formula. Derivative of sin inverse of x is 1 by root of 1 minus x square, right? D by dx of sin inverse of x. What is derivative of sin inverse of x? Derivative of sin inverse of x is 1 by root of 1 minus x square. 1 by root of 1 minus x square. So derivative of sin inverse of x power 3 by 2 is differentiate sin inverse of x and further differentiate x power 3 by 2 using derivative of x power n formula. What should I write now? dy by dx equal to, when you differentiate y with respect to x, I'm going to get dy by dx. Derivative of sin inverse of x, 1 by square root of 1 minus x square. So what should I write now? 1 by square root of 1 minus x power 3 by 2 square. Correct? X power 3 by 2 square into derivative of x power 3 by 2. 3 by 2 x power 3 by 2 minus 1. Correct? Derivative of sin inverse of x. 1 by square root of 1 minus x square. Instead of x, what we have is x power 3 by 2. X power 3 by 2 square into derivative of x power 3 by 2. 3 by 2 x power 3 by 2 minus 1. Correct? So this becomes equal to what? 3 by 2 I shall write first. 3 by 2 I wrote. 3 x power 3 by 2 minus 1. 3 by 2 minus 1 is half. X power half. Correct? Divided by square root of 1 minus x power 3 by 2 square is x cube. 3 root x divided by 2 into root of 1 minus x cube. Correct? 3 by 2 minus 1 is half. X power half is root x. So 3 root x by 2 into root of 1 minus x cube. Here the powers gets multiplied. 3 by 2 into 2 becomes 3. So x cube. Correct? This is the answer. I excluded the endpoints, okay, because 0 can be included, I think, but 1 cannot be included, correct? So I take always the open interval, that's better. If you include 0, 3 into 0, 0, correct? Of course, numerator becomes 0, denominator is non-zero. But when you include 1, no, denominator is becoming 0. That means the derivative does not exist. Better always take the open interval, okay? Move on to the next one. Differentiate cos of a cos x plus b sin x for some constants a and b with respect to x. Take the given function as y. Let y be equal to cos of a cos x plus b sin x. A and b are constants here. For some constants a and b mentioned clearly. So differentiate this dy by dx. Differentiate with respect to x on both sides. Differentiate with respect to x on both sides. This implies dy by dx. Dy by dx equal to derivative of cos is minus sine. Minus sine of what is there inside the bracket, same thing, right? Further differentiate a cos x plus b sin x by chain rule. Derivative cos is minus sine. Minus sine of, same thing you write. Minus sine of a cos x plus b sin x into, further differentiate the terms inside the bracket. What is there inside the bracket? A cos x plus b sin x. Differentiate that. To differentiate a cos x means it is constant into variable. Whenever I get constant into variable, constant keep as it is, differentiate the variable. Correct? A into derivative of cos x is minus sin x plus b into sin x. Constant into variable, constant keep as it is. Differentiate sin x, we get cos x. Correct? This is the answer. Derivative of cos, start from the outermost function. Derivative of cos is minus sine. Minus sine of what is there inside the bracket, same thing you write. Further differentiate terms inside the bracket. Derivative of a cos x is a into minus sin x. Derivative of b sin x is b cos x. Hope I understand. So if you want, you can write this term first, then you can write this, or keep as it is, doesn't matter. Okay. This is one term, actually, one function, minus sine of a cos x plus b sin x multiplied by minus a sin x plus b cos x. Hope you understand how to differentiate a composite function. Start from the outermost function. Derivative of cos is minus sine of same thing you write. Whatever is given, same thing you write. Further differentiate terms inside the bracket. Derivative of a cos x minus a sin x. Derivative of b sin x is b cos x. Constant into variable, how to differentiate? Constant keep as it is, differentiate the variable. Okay. Move on to the next one. Question number 5. Differentiate cos inverse x by 2 divided by square root of 2x plus 7. Domain is given, x lying between minus 2 plus 2 with respect to x. Okay, take the given function as y. Let y be equal to cos inverse x by 2 divided by square root of 2x plus 7. To differentiate this, we shall apply the quotient rule. Because it is quotient of two functions, we will apply quotient rule or u by v rule. What does quotient rule says? Denominator square. Square the denominator. In the numerator, you start from denominator. Denominator into derivative of numerator minus numerator into derivative of denominator. Correct? Differentiate with respect to x on both sides. Apply quotient rule or u by v rule. Differentiate with respect to x on both sides. Y is u by v rule. How to find the derivative? Dy by dx. Denominator square. I am writing the quotient rule here. Denominator square. Denominator keep as it is. Differentiate the numerator. Minus numerator into. Differentiate the denominator. Denominator into derivative of numerator. Dash indicates the derivative. Correct? Denominator keep as it is. Differentiate the numerator. Minus numerator keep as it is, differentiate the denominator. U by v rule or quotient rule, quotient of two functions. Whenever there is numerator by denominator, whenever there is quotient of two functions, apply this quotient rule. So dy by dx here. When you differentiate y with respect to x, I am going to get dy by dx. Dy by dx is equal to, here use quotient rule, denominator square. Denominator is root of 2x plus 7. Square it. Denominator square. In the numerator, start from denominator. Denominator into derivative of numerator. Correct? Root of 2x plus 7 into d by dx of cos inverse x by 2. Correct? Minus cos inverse x by 2 into derivative of root of 2x plus 7. D by dx of root of 2x plus 7. Hope you understand the quotient rule. Correct? Denominator square. In the numerator, start from denominator. Denominator keep as it is. Differentiate the numerator. Minus numerator keep as it is. Differentiate the denominator. Correct? That is the process. How to differentiate using quotient rule. Denominator, that is root of 2x plus 7. Keep as it is. Derivative of cos inverse x. Or derivative of cos inverse x minus 1 by root of 1 minus x square. Correct? But instead of x, what is given is x by 2. Further, we need to differentiate x by 2. Derivative of cos inverse x is minus 1 by square root of 1 minus x square. But instead of x, what we have is x by 2. So what I am going to write here? Minus 1 by square root of 1 minus x by 2 square. X by 2 square into derivative of x by 2, which is 1 by 2. Minus cos inverse x by 2 into derivative of root. Derivative of root x is 1 by 2 root x. So 1 by 2 root of 2x plus 7. 1 by 2 root of 2x plus 7 into derivative of 2x plus 7 is 2. Whole thing is divided by denominator square. Root of 2x plus 7 square is 2x plus 7. Then take LCM. 1 minus, this is x square by 4. Correct? 1 minus x square by 4. Take common denominator. Take LCM inside the root and simplify it further. Further we can simplify. This 2 will cancel. Correct? Derivative of root x, 1 by 2 root x. Further differentiate terms inside the root. Derivative of 2x is 2. Derivative of 7 is 0. Correct? So further I am differentiating 2x plus 7, which is 2. By chain rule it follows. Derivative of root x, 1 by 2 root x. But this is not x. So further differentiate. Derivative of 2x plus 7 is 2. Correct? Here x square by 4. root of 1 minus x square by 4. That is root of 4 minus x square by 4. Root 4 is 2. Correct? So what I am getting is equal to root of 2x plus 7 minus is there minus root of 2x plus 7 minus root of 2x plus 7, correct, minus root of 2x plus 7 divided by root of, I am taking LCM, x square by 4 it is, take LCM and write 4 minus x square by 4, correct, this is 4 minus x square divided by root 4, root 4 is going to be 2, like this I am getting, into 1 by 2 is there, into 1 by 2, correct, minus this 2 will cancel. So what is left? Cos inverse x by 2, cos inverse of x by 2 divided by square root of 2x plus 7 divided by 2x plus 7 divided by 2x plus 7. Here this 2 and 2 will cancel. This 2 will cancel. Take common denominator here. Correct? So what I am going to get is here LCM is root of 4 minus x square into root of 2x plus 7. Correct? Root of 4 minus x square into root of 2x plus 7. Numerator will be minus of root 2x plus 7 into root 2x plus 1. That is minus of 2x plus 7. Correct? Minus cos inverse x by 2 into root of 4 minus x square. Cos inverse x by 2 into root of 4 minus x square. Correct? Whole thing is divided by 2x plus 7. If you want, you can take minus and common and this will come to denominator. Hope you understand. If you want, I can write in a better way. I think this is taking more steps actually. I'll rub this part. Quotient rule. Quotient rule is not required here. Already we applied the quotient rule. So anymore it's not required. If it's confusing for you, I shall write here the numerator. This much is there. Correct? I shall write here. Correct. This 2 got cancelled. These steps are clear, no? X square by 4. I took LCM as 4 inside the root. So I get 4 minus x square by 4. Root of 4 minus x square by root 4 is 2. This 2 and this 2 got cancelled. So what is left here is take LCM here. LCM will be root of 4 minus x square into 2x plus 7. Root of 4 minus x square into root of 2x plus 7. Correct? So this root of 4 minus x square, I have to multiply by root of 2x plus 7 to get this. That root into this root will cancel, becomes minus of 2x plus 7. Correct? And this into this, minus cos inverse x by 2 minus cos inverse x by 2 into root of 4 minus x square. Whole thing is divided by 2x plus 7. This is the answer. If you want, you can bring these two to denominator. Okay. If you want, I can take a minus and common here. So I'll write the answer here. Dy by dx if you want. Dy by dx. Dy by dx is equal to what? Where shall I write the dy by dx? Dy by dx I'll write here itself. Taking minus and common there. Okay. So dy by dx equal to. I shall write here otherwise. Dy by dx equal to. Dy by dx is equal to what? Minus and common, minus of, what you get? 2x plus 7, 2x plus 7, plus cos inverse x by 2, cos inverse x by 2, into root of 4 minus x square, close the bracket, divided by, this will come to denominator, root of 4 minus x square, root of 4 minus x square. This 2x plus 7 into root of 2x plus 7. That becomes 2x plus 7 power 3 by 2. Correct? See, 2x plus 7 means 2x plus 7 to the power 1. Root of 2x plus 7 is 2x plus 7 to the power half. Multiplying means adding the powers. 1 plus half, 1 and half, 3 by 2. So this becomes 2x plus 7 to the power 3 by 2. That's the answer. Simplified form. Apply quotient rule properly and get the answer. Okay. I wrote after this step here, then I wrote here, then the answer is written here. Hope you understand. Move on to the next one. Differentiate square root of 3x plus 2 plus 1 by root of 2x plus 4 with respect to x. Take the given function as y. Let y be equal to this. Let y is equal to square root of 3x plus 2 plus 1 by square root of 2x square plus 4. Differentiate this. Find dy by dx. Derivative of root x. Derivative of root x is 1 by 2 root x. But this is not x. So further differentiate 3x plus 2, which is 3. This takes the form 1 by x. Derivative of 1 by x is minus 1 by x square. And this is not x. I am taking the form of 1 by x. But this is not x. So further differentiate root. Derivative of root is 1 by 2 root x. And further differentiate terms inside the root, which is 4x. Correct? dy by dx. Differentiate with respect to x. dy by dx will be equal to dy by dx. Derivative of root x. Derivative of root x is 1 by 2 root x. 1 by 2 root of 3x plus 2 into derivative of 3x plus 2, that is 3. Further differentiate terms inside the square root. Derivative of 3x plus 2 is 3. 3 into 1 plus 0. Here derivative of 1 by x. Derivative of 1 by x is minus 1 by x square. Correct? So differentiate as a differentiate 1 by x. Treat this entire thing as x in your mind. Okay? Derivative of 1 by x minus 1 by x square. So this is minus 1 by root of 2x square plus 4 the whole square. Correct? Into derivative of root. Derivative of root is 1 by 2 root. 1 by 2 root of 2x square plus 4 into derivative of 2x square plus 4. Derivative of 2x square, 2 into 2x is 4x. And derivative of 4 is 0. Correct? So what we get is 3 by 2 into root of 3x plus 2. Correct? Here 2 1s are, 2 2s are cancels. What is left? Minus 2x divided by root of 2x square plus 4 square is 2x square plus 4. Correct? Square root means to the power half. The powers gets multiplied. Half into 2 is 1. The power is 1 here. 2x square plus 4 to the power 1. This is 2x square plus 4 to the power half. Square root means to the power half. So what we get is 3 by 2 root of 3x plus 2 minus 2x divided by 2x square plus 4 to the power 1 plus half, that is 3 by 2. Correct? Derivative of 1 by x minus 1 by x square, but this is not x. So further differentiate. Derivative of root is 1 by 2 root. 1 by 2 root of 2x square plus 4. The derivative of 2x square plus 4. Derivative of 2x square is 4x. 2 1s are 2 2s are. Minus 2x by. Here root of 2x square plus 4 square is 2x square plus 4. Root means to the power half. Multiply means adding the powers. 1 plus half. 1 and half is 3 by 2. So we get like this. Once again I explain. Derivative of 1 by x form. Derivative of 1 by x is minus 1 by this entire thing square. But this entire thing is not x. It is root. So further differentiate root. Derivative of root is 1 by 2 root. 1 by 2 root of what is the same thing, right? Further differentiate terms inside the root. Derivative of 2x square is 4x. Derivative of 4 0. 2 1s are 2 2s are cancels. Minus 2x by root of 2x square plus 4 square will be 2x square plus 4. Correct? And this is to the power half. Multiplying means adding the powers. 1 plus half. 1 and half. 3 by 2. Move on to the next one. Differentiate e power secant square x plus 3 cos inverse x with respect to x. Take the given function as y. Let y is equal to e power secant square x plus 3 cos inverse x. Differentiate this. Dy by dx. You know derivative of e power x. Derivative of e power x is e power x. Differentiate as a differentiate e power x. Derivative of e power secant square x is e power secant square x into further differentiate secant square x. To differentiate secant square x, it takes the form x square. Derivative of x square is 2x. Derivative of secant square x is 2 secant x into derivative secant x tan x. Derivative of e power secant square x. E power secant square x into derivative of secant square x is 2 secant x into derivative of secant x is secant x tan x. Hope you understand. Derivative of e power x is e power x, but this is not x. So further differentiate secant square x. Derivative of secant square x is 2 secant x into derivative of secant x, which is secant x tan x. Here constant into variable. Constant keep as it is. Derivative of cos inverse x is minus 1 by root of 1 minus x square. Derivative of cos inverse x minus 1 by root of 1 minus x square. So this is equal to what? 2 into secant x into secant x is secant square x into tan x into e power secant square x, correct? Plus into minus will be minus 3 divided by root of 1 minus x square. Correct? Once again I explain. Derivative of e power x is e power x. But this is not x. So further differentiate secant square x. How do you differentiate secant square x? Differentiate secant square x as you differentiate x square. Derivative of x square 2x. Likewise, derivative of secant square x is 2 secant x into further differentiate secant x, which is secant x tan x. Constant into variable. Constant keep as it is. Derivative of cos inverse x is minus 1 by root of 1 minus x square. So first I write the number 2 here. 2 into constant to keep first. Secant x into secant x becomes secant square x into tan x into e power secant square x. Plus into minus is minus 3 by root of 1 minus x square. That's it. Move on to the next one. Y is equal to log x to the base 7. Find dy by dx. The 7th one, this is 8th. Okay. Take given y equal to log x to the base 7. Find dy by dx. Here you must know the formula for derivative of log x base a. What is derivative of log x base a? D by dx of log x base a. Derivative of log x base a is equal to what? 1 by x into log e base a. Correct? This is a formula. Derivative of log x base a is 1 by x into log e base a. I'll be using this formula here to differentiate log x base 7. Derivative of log x base e is 1 by x. Note down derivative of log x base e. Log x means log x base e, correct? Log x is same as log x base e, which is 1 by x. Here derivative of log x base a is given. In that case 1 by x into log e base a. I am using this formula here in this problem because base is not e here. If no base is given, you can take the base as e. Inside the bracket log x is there. Their base is not mentioned. That means you can take the base as e. Because e is the standard base, the base of the natural logarithms. Okay, e is the base of the natural logarithms or log x base e or ln x also you can write. So here the base is e. If no base is mentioned, you can take the base as e. Here the base is mentioned as 7. So you can't take it as e. You should take it as a in general. So log x base a. So differentiate this. Dy by dx. Dy by dx equal to derivative of log is 1 by. So 1 by log x. 1 by log x into log e base 7. Correct? Into further differentiate log x. Derivative of log x is 1 by x. Derivative of log is 1 by. So 1 by log x into log e base 7 using this formula. Now further differentiate log x. Derivative of log x means log x base which is 1 by x. Correct? By using chain rule. You can rewrite this as log e base 7. Log e base 7 divided by x log x. That's it. Over. If you want, you can use change of base rule and get the answer also. But this is easier. Learn this formula if you have not learned. Derivative of log x base is 1 by x into log e base a. Derivative of log x is 1 by x. If the base is not given, take the base as e, the standard base. Okay. Here the base is mentioned as 7, so we can't use this formula. At first I am using this formula. To differentiate the inner one, that is to differentiate the terms inside the bracket, I am using this formula. Derivative of log x, which is 1 by x. It follows by chain rule. Move on to the next one. Using the fact that sin of a plus b equal to sin a cos b plus cos a sin b and the differentiation, we have to obtain the sum formula for cosines. That means you have to get the formula for cos of A plus B. What is cos of A plus B? Cos A cos B minus sin A sin B. I should get that formula using this formula and by using the concept of differentiation. So I need to differentiate this. I'll take A and B as a function of x. What I do? Take A and B as functions of x. Let us assume that A and B are functions of x. Let us assume that A and B, let us assume that A and B are functions of x. A and B are functions of x. Okay. Consider sine of A plus B now. Consider sine of A plus B. Consider sine of A plus B, which is equal to sin A cos B plus cos A sin B. Sin A cos B plus cos A sin B. Differentiate with respect to x on both sides. Consider this formula, what is given. Differentiate with respect to x on both sides. Differentiate with respect to x on both sides. Derivative of sine of A plus B is, derivative of sine is cos. Cos of A plus B into derivative of A plus B. Derivative of A with respect to x, dA by dx. Derivative of B with respect to x, dB by dx. Okay. So, derivative of sine of A plus B is cos of A plus B. Cos of A plus B into derivative of A plus B. Derivative of A is dA by dx. Further differentiate. Derivative of B with respect to x, dB by dx. Here you can apply the product rule. It's multiplication of two functions, correct? First into derivative of second plus second into derivative of first. Apply product rule first. Here also apply product rule. Okay? Applying product rule here, or the UV rule we call. Leibniz rule also. First function keep as it is, sin A. Differentiate the second function, derivative of cos B, d by dx of cos B plus cos B into d by dx of sin A, d by dx of sin A plus this part is over. Come into this part. Here also you need to apply the product rule. First function keep as it is, cos A into d by dx of sin B plus sin B into d by dx of cos A. So what do you get? This is this part. Sin A into derivative of cos B. Derivative of cos B is minus sin B into dB by dx. Derivative of cos B is minus sin B into dB by dx. Correct? Plus cos B into derivative of sin A. Derivative of sin A is cos A into derivative of A with respect to x, dA by dx. Plus cos A into derivative of sin B, cos B into further differentiate B with respect to x, dB by dx. Here sin B into derivative of cos A. Derivative of cos A is minus sin A into further differentiate A with respect to x, dA by dx. You can take dB by dx common between these two. Between these two, dB by dx is common, right? dB by dx is common. So what remains? If you take dB by dx common, dB by dx common, what remains? Cos A cos B minus sin A sin B. Cos A cos B minus sin A sin B. Here dA by dx is common between these two. dA by dx is common. dA by dx common. So what remains is cos A cos B minus sin A sin B. Cos A cos B minus sin A sin B. Now see, cos A cos B minus sin A sin B is common. So what remains is dA by dx plus dB by dx. This entire thing is common, correct? So what is common here? Cos A cos B minus sin A sin B is common. Cos A cos B minus sin A sin B is common. So what remains is dA by dx plus dB by dx. Correct? So that left hand side what we have? Cos of A plus B into dA by dx plus dB by dx. So dA by dx plus dB by dx is going to cancel on either sides. Correct? dA by dx plus dB by dx is going to cancel. So what we get is cos of A plus B equal to cos A cos B minus sin A sin B. Hence proved. So starting from sin of A plus B equal to sin A cos B plus cos A sin B. And using the concept of differentiation, we got the sum of the cosine function. Some formula for cosines. That is cos of A plus B equal to cos A cos B minus sin A sin B. Hence proved. Hope you understand. Take A and B as functions of x. Derivative of sin is cos. Cos of A plus B into derivative of A plus B. dA by dx plus dB by dx follows by chain rule. Further differentiate A with respect to x. Further differentiate B with respect to x. Here apply product rule. Here also apply product rule. First function keep as it is. Differentiate the second function. Plus second function keep as it is. Differentiate the first function. Here also same thing. Applying product rule. First function keep as it is. Differentiate the second function. Plus second function keep as it is. Differentiate the first function. Move on to the next one. Next we got the questions on implicit function differentiation. Already we know what is implicit function differentiation. X and y are present on the same side of the equation. It's called as implicit function. F of x comma y equal to 0. Finding the derivatives of implicit function is called as implicit function differentiation. Here we can rewrite this equation. What is given? Cos y is equal to x into cos of a plus y. Given cos y is equal to x into cos of a plus y. There are different methods of solving this problem. I'll do it by using the quotient rule. I'll express this as quotient of two functions. I'll express this as x as a function of y. So from this I can rewrite it as cos y divided by cos of a plus y is equal to x. Cos y divided by cos of a plus y is equal to x. Differentiate with respect to x on both sides. Differentiate with respect to x on both sides. Differentiate with respect to x on both sides. For left hand side we shall apply the quotient rule. Okay. So that cos square a plus y. See, cos square a plus y is in the numerator. That after cross multiplying it goes to numerator. I am differentiating with respect to x on both sides. For left hand side I am applying quotient rule, u by v rule. So denominator square cos square of a plus y. Denominator square. Denominator into derivative of numerator. Cos of a plus y. Denominator keep as it is. Differentiate the numerator. D by dx of cos y. Minus cos y into d by dx of cos of a plus y. Is equal to derivative of x is 1. Correct? Denominator square, denominator keep as it is, differentiate numerator minus numerator keep as it is, differentiate the denominator, quotient rule. Correct? And right hand side, derivative of x with respect to x is 1. So derivative of cos y minus sin y into dy by dx. Derivative of cos a plus y minus sin of a plus y into derivative of a plus y. Derivative of a is 0 because a is constant. Derivative of y is dy by dx. Correct? So from this cos a plus y, I'll write here cos of a plus y into here derivative of cos y with respect to x. Derivative of cos y is minus sin y into derivative of y with respect to x, dy by dx. So what should I write here? Minus sin y into dy by dx. Minus cos y into derivative of cos of a plus y. Derivative of cos is minus sin of a plus y into dy by dx minus sin of a plus y, correct, into derivative of a plus y. Derivative of a is 0. Derivative of y is dy by dx. dy by dx. Denominator is cos square of a plus y, correct? Cos square of a plus y is equal to 1 is there, correct? Is equal to 1, I'll write here itself. Is equal to 1. Is equal to 1, I wrote here. This is cross multiply. So what do you get? Cos square of a plus y is equal to 1, I'll write here, okay? Is equal to 1, I wrote here. So cross multiply, this is what we get. Cos square a plus y into 1. Cos square of a plus y is equal to, here I can take dy by dx common. Minus into minus plus here. Take dy by dx common from this. If you take dy by dx common, what remains? First I'll write this term because minus into minus plus. So what remains here? Sin of a plus y into cos y. Sin of a plus y into cos y minus cos of a plus y into sin y. Cos of a plus y into sin y. Correct? So what we get here? This is cos square a plus y. Cos square of a plus y is equal to dy by dx into terms inside the bracket takes which form? Sin a cos b minus cos a sin b. Correct? This takes the form sin a cos b minus cos a sin b, which is sin of a minus b. Correct? This becomes sin of a minus b. So sin of, what I'm going to get? A plus y minus y, correct? A plus y minus y. Like this. Sin a cos b minus cos a sin b, which is sin of a minus b. Sin of a plus y minus y. Plus y minus y will add up to 0, correct? Plus y minus will add to 0 becomes sin a here. So dy by dx into sin a. So dy by dx I'll get. Dy by dx into what is left here is sin a. So dy by dx equal to what? Cos square a plus y divided by sin a. Correct? Dy by dx is cos square of a plus y divided by sin a. Hence we get cos square of a plus y divided by sin a. This is the answer. Hope you understand this by applying quotient rule. Rewrite the given equation as x is equal to cos y divided by cos of a plus y. Then apply quotient rule. Differentiate with respect to x on both sides. Denominator square. Denominator keep as it is. Differentiate numerator. Minus numerator keep as it is. Differentiate the denominator. Derivative of cos y is minus sin y into dy by dx. Correct? Derivative of cos a plus y is minus sin a plus y into derivative of y dy by dx. Derivative of a is 0. Derivative of y is dy by dx. Derivative of x with respect to x is 1. Correct? Then you cross multiply this. 1 into cos square a plus y is cos square of a plus y. Then take dy by dx common here. Dy by dx common. First I am writing this term. Minus into minus is plus. First I am writing this. Sin of a plus y into cos y minus cos of a plus y into sin y. This terms inside the bracket takes the form sin a cos b minus cos a sin, which is sin of a minus b. Terms inside the bracket is taking this form. Sin a cos b minus cos a sin b, which is sin of a minus b. My angle A is a plus y. Angle B is y. Angle A is a plus y. Angle B is y. Sin of a minus b formula. Plus y minus y cancels. We get sin a. Sin a bring it down. So dy by dx is cos square a plus y divided by sin a. Proved. Next one we got x into root of 1 plus y into root of 1 plus x equal to 0. For x not equal to y, x lying between minus 1 plus 1, show that dy by dx equal to minus 1 by 1 plus x the whole square. So given equation, we're going to simplify it first. Okay, don't differentiate this directly. To get the answer, they use quotient rule here, because the square is there in the denominator, means normally they apply quotient rule and get the answer, dy by dx. So we have to simplify this so that I have to express it as quotient of two functions. I have to express y as the quotient of two functions, then apply quotient rule. For that you have to simplify more here. Okay, x into root of 1 plus y into root of 1 plus x equal to 0. That you have to simplify using quotient rule. So given equation is given. Rewrite this equation. X into root of 1 plus y, x into root of 1 plus y is equal to minus y into root of 1 plus x. Correct? X into root of 1 plus y is equal to, this term is shifted to that side, minus y into root of 1 plus x. Squaring on both sides. We'll do squaring on both sides. What we get? X square into 1 plus y. Square this. X becomes x square. Root 1 plus y square, 1 plus y is equal to, minus square is plus y square into 1 plus x. Correct? Square this, x square into root 1 plus y square is 1 plus y. Minus y square is same as y square. Root 1 plus x square is 1 plus x. So go on, simplify it. Open this bracket. What do we get? X square into 1. X square into 1 is x square. Plus x square into y. Get x square y is equal to y square into 1, that is y square. Plus y square into x, that is y square x. From this, simplify further. I rearrange the terms here. X square minus y square is equal to y square x minus x square y. Y square x minus x square y. Correct? This term take that side. Y square shifted to left hand side. X square y bring it to right hand side. X square minus y square, you can factorize it as x plus y into x minus y. Factorize this and take common terms. Left hand side, x plus y into x minus y. Here xy is common. Xy common means what remains is y minus x. If we cancel x minus y and y minus x, I am going to get minus 1. X minus y is minus 1 into y minus x. And I can cancel this because they told x not equal to y. Given that x not equal to y, as x is not equal to y, I can write x minus y is not equal to 0. If a number is not equal to 0, I can cancel it. But x minus y and y minus x, they are not exactly same. Correct? If x minus y is positive, y minus x is negative. It is like 3 minus 5 and 5 minus 3. 3 minus 5 is minus 2. 5 minus 3 is 2. They are not exactly same. Correct? If you cancel x minus y and y minus x, I am going to get minus 1. So what is left here? X plus y is equal to minus 1 into xy is minus xy. Correct? Minus xy, bring it to left hand side, becomes plus xy. So I can write this as x plus xy equal to 0. Writing all the terms to one side, x plus y plus xy equal to 0. Now I can take y common between these two, or else I can take x common between these two. Okay, because x is present here, x is present here. You can take x common from the first and third term, or else I can take y common from the second and third term. But what I'll do is I'll take y common, because my aim is to express y as a function of x. I want to express y as a function of x, so I'll take y common here. I'll not take x common. Okay, so x you keep as is. X plus, here I'll take y common. Y common, what you get is 1 plus x is equal to 0. Taking y common between the second and third term. I shall not take x common between the first and third term. That I will not do. Because I want to express y as a function of x, then apply quotient rule. And that too, when you express y as a function of x, no, I can give guarantee that because denominator is 1 plus x the whole square, I should get y is equal to numerator is some function, denominator is guaranteed it is 1 plus x. Because they apply quotient rule and get the answer. I should get 1 plus x in the denominator. In such a way I am adjusting it. I am simplifying it. Okay. So from this y into 1 plus x, y into 1 plus x is equal to, this x you take the answer becomes minus x. Therefore, I got finally y as the quotient of two functions, minus x divided by 1 plus x. At this stage, so far I have not differentiated at all. Just go on simplifying it, correct? Now at this stage, I'll differentiate. Okay? Differentiate with respect to x on both sides. Differentiating with respect to x on both sides. What do you get? dy by dx. dy by dx is equal to denominator square into derivative of numerator d by dx of minus x minus x into d by dx of 1 plus x. So this is equal to what? 1 plus x into derivative of minus x, that is minus 1, minus of minus becomes plus x. Derivative of 1 plus x is 1. Derivative of 1 0. Derivative of 1 is 0. Derivative of x 1. 0 plus 1 is 1. Correct? Divided by denominator is 1 plus x the whole square. So 1 into minus 1 minus x plus x. Therefore, I'll get the answer. dy by dx equal to minus 1 by 1 plus x the whole square. If you want, I'll write here last step. I'll write here. The last step is dy by dx is equal to dy by dx is equal to what? 1 into minus 1 is minus 1. X into minus 1 is minus x. Plus x into 1 is x. Divided by 1 plus x the whole square. Minus x plus x will add up to 0. So I get minus 1 by 1 plus x the whole square. So dy by dx is got minus 1 by 1 plus x the whole square. Once again, give an equation, x into root of 1 plus y into root of 1 plus x equal to 0. From this, one of the terms shifted to right hand side. So what we get? X into root of 1 plus y equal to minus y into root of 1 plus x. Do squaring on both sides because I want to simplify it. I want to simplify so that I get y as a function of x. That too, y is equal to numerator is some function of x and denominator is 1 plus x, and apply quotient rule so that we get dy by dx in this form. So for that we are simplifying it. Squaring on both sides, x becomes x square. Root 1 plus y becomes 1 plus y. Minus y square is same as y square. Root 1 plus x square is 1 plus x. Open the bracket. X square into 1 x square. X square into y, x square y. Y square into 1 y square. Y square into x, y square x. X square minus y square. Rearrange the terms. Y square x minus x square y. Here you can factorize x plus y into x minus y. Here you can take x, y common. You get y minus x. If you cancel x minus y and y minus x, I get minus 1. Minus 1 into xy is minus xy. Bring this to left hand side. So get x plus y equal to 0. I'll take y common here. Even though I can take x common between the first and the third term, I shall not take x common. I'll take y common here. So taking y common between the second and the third term. Y is out. So what remains? 1 plus x. So y into 1 plus x equal to minus x. So y is equal to minus x by 1 plus x. Differentiate with respect to x by using quotient rule. Okay. And get the answer. Quotient of two functions. So apply the quotient rule. Denominator square. Denominator keep as it is. Differentiate the numerator. Derivative of minus x is minus 1. Correct? Minus. Numerator into. Differentiate the denominator. Derivative of 1 plus x is 1. So 1 into plus x plus x. 1 into minus 1 minus 1. x into minus 1 minus x plus x will add up to 0. So I'm getting dy by dx equal to minus 1 by 1 plus x the whole square. Hence proved. Move on to the next one. Questions on derivatives of inverse trigonometric functions. There are some questions. Find dy by dx if y is equal to sin inverse of x plus sin inverse of root 1 minus x square. X lies between 0 and 1. Whenever there is root of 1 minus x square, we make a substitution x equal to sin theta, correct? So put x equal to sin theta and simplify it and then differentiate. Put x equal to sin theta. Put x equal to sin theta. What we get? Y is equal to sin inverse of sin theta, putting x equal to sin theta, plus sin inverse of root of 1 minus sin square theta. In place of x, we put sin theta. Sin inverse of sin theta is theta, assuming that theta lies in the principal branch. Of course, x is between 0 and 1. So sin theta is between 0 and 1. So theta lies between 0 and pi by 2, correct? They told x is between 0 and 1, correct? So sin theta is between 0 and 1. Sin theta lies between 0 and 1. So theta lies between 0 and pi by 2. Sin inverse of 0 is 0. Sin inverse of 1 is pi by 2. Theta lies between 0 and pi by 2. Correct? Sin inverse of sin theta is equal to theta because theta lies in the principal branch of sin inverse, which is closed interval minus pi by 2 to pi by 2. This is the part of the principal branch of sin inverse. So we could write this. Next term is sin inverse of 1 minus sin square theta is cos square theta and root of cos square theta is cos theta. Root of cos square theta is mod of cos theta. Mod of cos theta is cos theta because theta lies in the first quadrant. 0 to pi by 2 is first quadrant. First quadrant cos function is positive. Every trigonometry function is positive, correct? 1 minus sin square theta is cos square theta. Root of cos square theta is equal to mod of cos theta. Mod of cos theta is equal to cos theta because cos theta is positive as theta lies between 0 to pi by 2. It's first quadrant. First quadrant, every trigonometry function is positive. So even cos function is positive. So this you can write it as theta plus sin inverse of, using the concept of allied angles, I can write cos theta as sin of pi by 2 minus theta. Sin of 90 minus theta, correct? So if you take pi by 2 minus theta, where it lies you can find out. If theta lies between 0 and pi by 2, minus theta lies between minus pi by 2 and 0, correct? From this, I can write theta lies between 0 and pi by 2, minus pi by 2 less than theta, less than minus theta less than 0, correct? When you multiply by minus 1, inequality is going to reverse, correct? By 0 greater than minus theta greater than minus pi by 2, I get. So pi by 2 minus theta means add pi by 2 for all. Pi by 2 minus pi by 2 0 less than pi by 2 minus theta less than pi by 2. So pi by 2 minus theta is lying in the first quadrant. So it is a part of the principal branch. So this is theta plus sin inverse of sin of pi by 2 minus theta is pi by 2 minus theta. Theta cancels. I am getting y equal to pi by 2. Pi by 2 is a constant. Derivative of constant is 0. So dy by dx equal to 0. Actually we can do it in a shorter way. But for board exams, if this question is asked, no, directly do like this as I have done. But we know that if x lies between 0 and 1, sin inverse of root 1 minus x square is cos inverse of x. It follows by inverse trigonometric function. And sin inverse of x plus cos inverse of x is pi by 2 is actually deleted from NCERT book, the properties of ITF. So pi by 2 becomes 2 steps I can write the answer actually, this problem. 2 steps I can write the problem. How to write? For x between 0 to 1, what we know? When x lies between 0 and 1, for x between 0 and 1, sin inverse of root of 1 minus x square is equal to cos inverse of x. Sin inverse of root 1 minus x square is equal to what? Cos inverse of x. Using this. Given function becomes what? Y is equal to sin inverse x plus cos inverse x. This is alternate method. Okay. Learn this. For x between 0 to 1, sin inverse of root 1 minus x square is cos inverse of x. You can convert, you can prove it. You can prove that easily by taking a triangle. Sine inverse means it is opposite by hypotenuse. Cos inverse is adjacent by hypotenuse. It's a very standard result. So sine inverse x plus cos inverse x. We know that sine inverse x plus cos inverse x is pi by 2. So dy by dx is equal to 0. Pi by 2 being a constant, derivative of constant is equal to 0. 2 lines we can get the answer. Okay. All these things not required. For board exams we can do the same method. Okay. As I've done like this. If it is asked. For MCQ you can answer it directly. Next one. Find dy by dx of y equal to tan inverse of sin x by 1 plus cos x. Inside the bracket there are trigonometric functions. We need to simplify this. Sin x we can use half angle formula. Sin x is 2 sin x by 2 cos x by 2. 1 plus cos x is 2 cos square x by 2. Correct? So y is equal to tan inverse of. Y is equal to tan inverse of. What is sin x? 2 sin x by 2 cos x by 2. 1 plus cos x. 1 plus cos x is 2 cos square x by 2. 2 cancels. 1 causal cancel. Sin by cos is tan. So you get tan inverse of tan x by 2. Tan inverse of tan x by 2. Tan inverse of tan x by 2 is equal to x by 2. X by 2 means half into x. Half into x. Correct? This is y as a function of x. Differentiate. dy by dx. Constant into variable. Constant keep as it is. Derivative of x with respect to x1. Half into 1 is half. So dy by dx is half. Simplify using half angle formula for numerator and denominator. Sin x is 2 sin x by 2 cos x by 2. 1 plus cos x is 2 cos square x by 2. 2 cancels. 1 causal cancel. Sin by cos tan. Tan inverse of tan x by 2 is x by 2. Assume that lies in the range of tan inverse. Okay. No conditions are given there. Tan inverse of tan theta is theta if theta lies in its principal branch. But x by 2, we assume that it lies in the principal branch. No conditions are given. So x by 2 is written as half into x. Constant into variable. Constant keep as it is. Differentiate x with respect to x1. So dy by dx is half. Move on to the next one. Find dy by dx if y equal to sin inverse of 2 power x plus 1 by 1 plus 4 power x. We can write this as y is equal to sin inverse of 2 power x plus 1. I can write 2 power x into 2 power 1 divided by 1 plus 4 is 2 square. 2 square to the power x. Correct? This is equal to sin inverse of 2 into 2 power x divided by 1 plus here 2 square power x. Correct? 2 square is 4. Correct? I'll interchange x and 2. X you bring inside, 2 you take outside. This becomes 2 power x square. Correct? This is 2 square power x. 2 square power x is 2 power x square. So I can put 2 power x equal to tan theta. In place of 2 power x, we can put tan theta. So this becomes sin inverse of what we get? Sin inverse of, in place of 2 power x, you put tan theta. So what you get is 2 tan theta divided by 1 plus tan square theta. Correct? 2 power x is tan theta. 2 power x is tan theta. So 2 tan theta by 1 plus tan square theta. Terms inside the bracket is sin 2 theta. So sin inverse of sin 2 theta I am getting. Sin inverse of sin 2 theta. Sin inverse of sin 2 theta is equal to 2 theta. Correct? Substitute back for theta finally. Theta is equal to tan inverse of 2 power x. Because 2 power x equal to tan theta. Theta is tan inverse of 2 power x. So this becomes 2 into tan inverse of 2 power x. Now differentiate with respect to x on both sides. If it is a CET problem, no, if it is asked for CET directly we can write. Also we know that sin inverse of 2x by 1 plus x square is 2 tan inverse x. I am doing all the steps because for board exams if it is asked, we can't jump, we can't write directly. You have to write all the steps in detail. That's why I am writing all the steps. Of course, we know that sin inverse of 2x by 1 plus x square is 2 tan inverse of x. Correct? Inverse trigonometry functions. We know this. That is applicable if x lies in the closed interval minus 1 to plus 1. Differentiability we discuss in the open interval. For differentiability, we take the open interval. If it is only inverse trigonometry function, it is valid even for closed interval. All those things we know. Directly, I could write it as 2 tan inverse of 2 power x, correct? But I am doing all the steps in detail so that it's helpful for you for writing the theory exams or the board exams. Okay. Now differentiate dy by dx. Dy by dx equal to constant into variable. Constant keep as it is. Differentiate tan inverse. Derivative of tan inverse x 1 by 1 plus x square. So derivative of tan inverse of 2 power x is 1 by 1 plus 2 power x square into derivative of 2 power x, that is 2 power x log 2. Further differentiate 2 power x. Derivative of tan inverse x is 1 by 1 plus x square. But instead of x, what we have is 2 power x. So further differentiate 2 power x. Differentiate tan inverse of 2 power x as a differentiate tan inverse x. Derivative of tan inverse x 1 by 1 plus x square. Derivative of tan inverse of 2 power x is 1 by 1 plus 2 power x square into further differentiate 2 power x, which is 2 power x log 2. So 2 power x into 2 becomes 2 power x plus 1. 2 power x plus 1 into log 2 divided by 1 plus 2 power x square. That is 2 you bring inside, x you take outside. It becomes a 2 square power x. 2 square is 4. So finally I am getting 2 power x plus 1 into log 2 divided by 1 plus 2 square is 4. 4 power x. Hope you understand. Got the answer like this. Move on to the next one. Given y equal to cot inverse root 1 plus sin x plus root 1 minus sin x by root 1 plus sin x minus root 1 minus sin x. X lies in the first quadrant. Find dy by dx. Simplify this. Simplify root of 1 plus sin x and root of 1 minus sin x. Okay. Simplify these two. Root of 1 plus sin x and root of 1 minus sin x. How do you simplify this? Root of 1 plus sin x if we consider. Root of 1 plus sin x. 1 could be written as cos square x by 2 plus sin square x by 2. 1 is cos square x by 2 plus sin square x by 2. Sin x is 2 sin x by 2 cos x by 2. Writing the half angle formula for sin x. 2 sin x by 2 cos x by 2. This takes the form a square plus b square plus 2ab. What is a square plus b square plus 2ab? A plus b the whole square. So this is equal to square root of cos x by 2 plus sin x by 2 the whole square. Cos x by 2 plus sin x by 2 the whole square. Square root of x square is mod x. Mod x is x if x is positive. So x by 2 lies in between 0 to pi by 4. No, x is between 0 to pi by 2. So x by 2 will lie between 0 and pi by 4. So 0 to pi by 4 means it's part of the first quadrant. Definitely cos and sin both are positive. So root of cos x by 2 plus sin x by 2 the whole square will be cos x by 2 plus sin x by 2. Similarly, simplify root of 1 minus sin x. Square root of 1 minus sin x is equal to 1 could be written as cos square x by 2 plus sin square x by 2. Cos square x by 2 plus sin square x by 2. Sin x we can write 2 sin x by 2 cos x by 2. Now it takes the form a square plus b square minus 2ab, which is a minus b the whole square. A square plus b square minus 2ab, which is a minus b the whole square. So this is equal to cos x by 2 minus sin x by 2 the whole square. Cos x by 2 minus sin x by 2 the whole square. Root of x square is mod x. Root of x square is mod x, correct? Root of x square is what? Mod x. Mod x is x if x is positive. Mod x is minus x if x is negative. Mod x is x if x is greater than or equal to 0. Mod x is minus x if x less than 0. Here you see that x lies between 0 and pi by 2. That means x by 2 will lie between 0 and pi by 4. 0 to pi by 4 cos values are bigger than sin values. Cos is bigger than sin. So higher value minus lower value means positive. Cos x by 2 minus sin x by 2 is positive. Because in the interval 0 to pi by 4, cos is bigger than sin. Correct? Cos x by 2 is bigger than sin x by 2. In the interval pi by 4 to pi by 2, sin is bigger than cos. At pi by 4, they become equal. We know this. Very interesting property of sin and cos in the first quadrant. 0 to pi by 4, cos values are bigger than sin value. So cos is bigger than sin means cos minus sin is positive. So this quantity is positive. So root of x square is actually mod x. I should write mod of cos x by 2 minus sin x by 2. Mod of cos x by 2 minus sin x by 2 becomes cos x by 2 minus sin x by 2 because it is positive. Cos x by 2 minus sin x by 2 is positive. So this simplifies to cos x by 2 minus sin x by 2. This is cos x by 2 plus sin x by 2. Correct? Remember this. Root of x square is equal to mod x. Mod x is equal to x if x is greater than or equal to 0. And it is minus x for x less than 0. So root of cos x by 2 plus sin x by 2 the whole square is, strictly speaking, I am at mod of cos x by 2 plus sin x by 2. Mod of cos plus sin, written as cos plus sin because it is already positive. Here also it is positive. Root of cos x by 2 minus sin x by 2 the whole square is mod of cos x by 2 minus sin x by 2. Mod of cos x by 2 minus sin x by 2 is cos x by 2 minus sin x by 2 because cos is bigger than sin. So cos minus sin is positive. Whenever you take square root of a number, answer what you get is non-negative. This is a positive value because shown here. In the interval 0 to pi by 4, cos is bigger than sin. So take this now. Substitute root of 1 plus sin x. I got simplified form cos x by 2 plus sin x by 2. Root of 1 minus sin x. Simplified form. I got cos x by 2 minus sin x by 2. So given expression, given equation becomes y equal to cot inverse of what we have. Root of 1 plus sin x. We got it as cos x by 2 plus sin x by 2. Cos x by 2 plus sin x by 2 plus root of 1 minus sin x is cos x by 2 minus sin x by 2. Cos x by 2 plus sin x by 2. This is cos x by 2 minus sin x by 2. Denominator is root of 1 plus sin x. Root of 1 plus sin x is cos x by 2 plus sin x by 2. Minus is there, correct? And root of 1 minus sin x is cos x by 2 minus sin x by 2. So this is equal to cot inverse of what we have. Sin x by 2 is going to cancel. Cos x by 2 plus cos x by 2 is 2 cos x by 2 divided by cos x by 2 is going to cancel. Minus into minus becomes plus. Sin x by 2 plus sin x by 2. 2 sin x by 2. 2 cancels. Cos by sin is cot. So I am getting cot inverse of cot x by 2. Cot inverse of cot x by 2. Cot inverse of cot x by 2 is x by 2. This is y. So differentiate this. dy by dx is half. Y is x by 2. So differentiate this. dy by dx. X by 2 means half into x. Derivative of x by 2 is half. Move on to the next one. Questions based on logarithmic differentiation. Find f dash of x if f of x given as sin x cos sin x. When do you apply log and differentiate? Whenever there is variable power variable, correct? U power v. U power v. Variable power variable is given as you take log on both sides and then differentiate, correct? Or else you can use the formula derivative of u power v. Derivative of u power v, I'll give the formula if you don't know. D by dx of u power v is u power v into derivative of v log u. This is quite useful. Derivative of u power v is u power v into d by dx of v log u. Okay, I'm using this formula. Directly I can get the answer. Otherwise, you can take log and differentiate. any method. Okay, f of x is given f of x is equal to sin x power sin x. Correct? Take log on both sides. Take log on both sides. What do you get? Log f of x is equal to log of sin x power sin x. Log of sin x to the power of sin x. Using the property, the power comes down. The power rule is there. Log a power b is b log a. So sin x comes down. So this becomes sin x log of sin x. Sin x log of sin x. I am taking log on both sides because there is variable power variable. Take log on both sides. The power comes down. Then differentiate with respect to x on both sides. Using property, simplified, then differentiate with respect to x on both sides. Derivative of log f of x, 1 by f of x into derivative of f of x is f dash of x. Correct? Derivative of log x is 1 by x. Derivative of log f of x is 1 by f of x into derivative of f of x, f dash of x. Here we need to apply the product rule. First function is sin x, second function is log of sin x. Apply product rule. First function keep as it is, differentiate the second function. The second function keep as it is, differentiate the first function. Sin x into derivative of log of sin x, d by dx of log of sin x, plus second function keep as it is, log of sin x into derivative of sin x is cos x, d by dx of sin x. So what do you get? This is equal to sin x into derivative of log of sin x is 1 by sin x into derivative of sin x, which is cos x, plus log of sin x into derivative of sin x is cos x. Here sin x will cancel. So you can take cos x common here. Correct? Cos x is common. What remains is 1 plus log of sin x. This is f dash of x divided by f of x. F dash of x divided by f of x. Cross multiplied. Therefore, I'll write the answer here. F dash of x is equal to f dash of x equal to f of x into cos x into 1 plus log of sin x. What is f of x? F of x is sin x more sin x. So this is sin x to the power sin x into cos x into 1 plus log of sin x. This is the answer. Whenever there is variable power variable, you take log on both sides. Or else you can use this formula also. Derivative of u power v into derivative of v log u. Can apply this formula and get the answer. Sometimes I'll be using this. Sometimes I'll take log and differentiate. Any method will do. Okay. Whenever there is variable power variable, you have to take log on both sides. Use the property of log and then differentiate. Okay. Log sin x power sin x. The power comes down. Then apply the product rule. For left hand side, derivative of log f of x. Derivative of log x is 1 by x. Derivative of log f of x 1 by f of x into derivative of f of x f dash of x. Here you apply the product rule. First function keep as it is. Derivative of log of sin x 1 by sin x into derivative of sin x is cos x, plus second function keep as it is. Derivative of sin x is cos x. Sin x will cancel. Take cos x common. Cos x common 1 plus log of sin x. Then cross multiply it. You get like this. Move on to the next one. Differentiate log x power log x for x greater than 1 with respect to x. Take the given function as y. Because there is variable power variable. Base contains x. Even the power contains x. So take log on both sides and differentiate. Take the given function as y first. Let y be equal to. Let y is equal to log x to the power log x. Y is equal to log x to the power log x. Taking log on both sides. Taking log on both sides, what do you get? Log y is equal to log of log x to the power log x. Taking log on both sides. Taking log on both sides. The power comes down. Correct? Log a power b is b log a, or log x power y is y log x. So this power comes down. This becomes log x into log of log x. The power comes down. Log x comes down. Differentiate with respect to x on both sides. Differentiate with respect to x on both sides. Derivative of log y is 1 by y into dy by dx. Derivative of log x is 1 by x. Derivative of log y with respect to x is 1 by y into dy by dx. Derivative of log y is 1 by y into dy by dx is equal to, here we can apply the product rule. First function keep as it is, differentiate the second function, plus second function keep as it is, differentiate the first function. Log x into derivative of log x. Derivative of log x is 1 by log x into derivative of log x, which is 1 by x, plus second function into derivative of first function. Second function keep as it is, log x into derivative of log x is 1 by x. Here log x is going to cancel. 1 by x is common here. Correct? 1 by x is common. So what remains is 1 plus log x. This is 1 by y into dy by dx. Correct? So from this I can write this y cross multiply and substitute back. Therefore, I can write dy by dx equal to dy by dx is equal to this y is cross multiplied to numerator of rx is y by x into 1 plus log x. What is y? You substitute back. What is y? Substitute back. Y is log x power log x. Correct? This is log x to the power log x, substituting back for y, log x to the power log x divided by x into 1 plus log x. Whenever they give variable for variable, take log on both sides, use the property of log and then differentiate. Okay. Derivative of log y is 1 by y into dy by dx. Here you apply the product rule. First function keep as it is, differentiate log x. Derivative of log x is 1 by log x into derivative of log x 1 by x, follows by chain rule. Plus second function keep as it is, differentiate the first function. Derivative of log x 1 by x. Log x will cancel. Take 1 by x common here. Then cross multiply it and get the answer. So dy by dx is equal to log x power log x divided by x into 1 plus log x. Hope you understand this. Applying product rule here, also apply chain rule to differentiate log x. This is the first function. This is the second function. Log x is first function. Log x is second function. First function keep as it is. Differentiate log x 1 by log x into derivative of log x 1 by x. Plus second function keep as it is, differentiate log x 1 by x. So 1 by x is common, correct? 1 by x is common. What remains is 1 plus log x. Cross multiplied and substitute back for y because you taken this as y. On to the next one. Differentiate sin x minus cos x to the power sin x minus cos x with respect to x actually. Okay, with respect to x you can write. Take this given function as y. Let y be equal to sin x minus cos x to the power sin x minus cos x. Sin x minus cos x whole to the power sin x minus cos x. Variable power variable is there. So take log on both sides. Take log on both sides. Use the property of log and then differentiate with respect to x to get dy by dx. Okay. Taking log on both sides, we get log y is equal to log of sin x minus cos x to the power sin x minus cos x. The power comes down using log, using property of log. The power is brought down, correct? This becomes sin x minus cos x, sin x minus cos x into log of sin x minus cos x. Now differentiate with respect to x on both sides. Differentiate with respect to x on both sides. Derivative of log y is 1 by y into dy by dx. Derivative of log x is 1 by x. Derivative of log x is 1 by x. Derivative of log y is 1 by y into dy by dx by chain rule. Further differentiate y with respect to x, dy by dx. Derivative of log x with respect to x is 1 by x. Derivative of log y with respect to x is 1 by y into further differentiate y with respect to x, dy by dx. Here you need to apply the product rule. Sin x minus cos x is first function. Log of sin x minus cos x is second function. Because it is product of two functions, you apply the product rule. First function keep as it is, differentiate the second function. Plus second function keep as it is, differentiate the first function. First function is sin x minus cos x, keep as it is. First function keep as it is. Differentiate the second function. Derivative of log of sin x minus cos x. Derivative of log x is 1 by x. Derivative of log of sin x minus cos x is 1 by sin x minus cos x. 1 by sin x minus cos x into further differentiate sin x minus cos x. Derivative of sin x is cos x. Derivative of minus cos x is plus sin x. Correct? First function write as it is. Differentiate the second function. Derivative of log x. Derivative of log is 1 by. So derivative of log of sin x minus cos x is 1 by sin x minus cos x into further differentiate sin x minus cos x. Derivative of sin x cos x. Derivative of minus cos x is plus sin x. Plus second function keep as it is. Log of sin x minus cos x. Second function keep as it is. Differentiate the first function. Differentiate the first function. Derivative of sin x minus cos x. Derivative of sin x is cos x. Derivative of minus cos x is plus sin x. So what do you get? This is into derivative of sin x is cos x. Correct? Derivative of minus cos x is plus sin x. Here sin x minus cos x is going to cancel. Correct? Sin x minus cos x is going to cancel. You can take cos x plus sin x common. So dy by dx is equal to, this you can cross multiply it. Dy by dx equal to, dy by dx is equal to, this 1 by y is brought to right hand side numerator, y into, what is common now? Cos x plus sin x is common, right? Cos x plus sin x is common. Cos x plus sin x is common. So what remains is 1 plus log of sin x minus cos x. Log of sin x minus cos x. What is y? You substitute back. Y is sin x minus cos x to the power sin x minus cos x. Substitute back finally. Sin x minus cos x to the power sin x minus cos x into what we have is cos x plus sin x into 1 plus log of sin x minus cos x. Hope you understand this. Variable power, variable is it? Take log on both sides. The power comes down. Log x power y is y log x. Then differentiate on both sides with respect to x. Here apply the product rule. First function keep as it is. Differentiate the second function. Derivative of log is 1 by sin x minus cos x into further differentiate sin x minus cos x. derivative of sine, cos, derivative of minus cos plus sine, plus second function keep as it is. Differentiate the first one. Derivative of sine is cos, derivative of minus cos plus sine. Then take cos x plus sin x common. What you get? 1 plus log of sin x minus cos x. Then cross multiply by and substitute back to get the answer. Move on to the next one. Differentiate x power x plus x power a plus a power x plus a power a for some fixed a greater than 0 and x is positive. Take this entire function as y. Let y be equal to this. Let y be equal to x power x plus x power a plus a power x plus a power a. Differentiate with respect to x each term. Differentiate with respect to x on both sides. Differentiate with respect to x on both sides. This gives dy by dx. dy by dx is equal to d by dx of x power x. d by dx of x power x plus d by dx of x power a plus d by dx of a power x plus d by dx of a power a. Derivative of a power a is 0 because a is constant. A power a is constant. Derivative of constant is 0. Derivative of a power x we know formula a power x log a. We know derivative of a power x, very standard. X power a, x is variable, a is constant, means variable power constant like x power n. Derivative of x power n is n into x power n minus 1. Instead of n they given a. So derivative of x power a is a into x power a minus 1. Okay, this is variable power constant. Variable power constant means we use the formula derivative of x power n. If it is constant power variable, we use the formula derivative of a power x log a. This is constant power variable. This is variable power constant. This is constant power constant. Constant power constant is constant. Derivative of constant is 0. And variable power variable means you should take log and differentiate. Correct? Variable power variable means you should take log and differentiate. Or derivative of u power v formula. Derivative of u power v is what? U power v into derivative of v log u. Correct? I'm using this. Derivative of u power v. Once I wrote earlier. Again I'm writing it. Derivative of u power v is equal to u power v into d by dx of v log u. So derivative of x power x is what? Derivative of x power x. Derivative of x power x will be x power x into d by dx of x log x. The power comes down. X log x. Correct? Derivative of x power x is x power x into d by dx of x log x. Derivative of v log u. Correct? So d by dx of x power x is, write the same thing. Whatever is given, same thing you write. X power x into d by dx of x log x. This will be equal to what? X power x into, to differentiate x log x, we apply the product rule. First function keep as it is, differentiate the second function. The second function keep as it is, differentiate the first function. How to differentiate this? X into derivative of log x is 1 by x plus log x into derivative of x is 1. Correct? First function keep as it is, differentiate log x 1 by x plus log x into derivative of x is 1. Correct? X cancels. What we get? X power x into 1 plus log x. X power x into 1 plus log x. So derivative of x power x is very standard actually. All these things required for competitive exams. You should learn it like anything. Okay. But since I'm doing for boards now, I'm writing all the steps. I know derivative of x power x is x power x into 1 plus log. It's a very standard. It's a very familiar result for CET and all. You should directly write for competitive exams. Since I'm doing it for board exams, I'm doing all the steps in detail. Understood? Derivative of x power x is x power x into 1 plus log x. Is shown, the steps are shown here in the side. Derivative of x power x is shown here. Derivative of u power v formula. U power v means u is a function of x, v is a power, v is also a function of x. Both the base and the powers are functions of x. Derivative of u power v into derivative of v log u. So derivative of x power x is x power x into derivative of x log x. To differentiate x log x, apply the product rule. First function keep as it is. Differentiate log x 1 by x plus second function keep as it is. Differentiate x1. X cancels. 1 plus log x into 1 plus log x. That is what I have. Derivative of x power a is a into x power a minus 1. A into x power a minus 1. Derivative of a power x is a power x into log a. Derivative of a power x is a power x into log a. And derivative of a power a is 0 because constant power constant is constant. Derivative of a power a is 0. Hope you understand all these things. Move on to the next one. Differentiate 5x to the power 3 cos 2x with respect to x. Take the given function as y. Take log on both sides. Then use the property of log and then differentiate to get dy by dx. Then cross multiply. Let y be equal to 5x to the power of 3 cos 2x. Because there is the base contains x, even the power contains x, we take log on both sides. Variable power variable, take log on both sides. What we get? Log y is equal to, taking log on both sides, log y is equal to log of 5x to the power of 3 cos 2x. Taking log on both sides. The power comes down using property of log. Log x power y is y log x. The power is brought down using the power rule for log. So this becomes equal to 3 cos 2x into log of 5x. Correct? 3 cos 2x into log of 5x. Differentiate with respect to x on both sides. Differentiate with respect to x on both sides. Derivative of log y is what? 1 by y into dy by dx. Derivative of log x is 1 by x. Derivative of log y 1 by y into dy by dx. Here apply the product rule. Taking this as first function, this is second function. 3 cos 2x is your first function. Log of 5x is your second function. Apply product rule then. First function keep as it is. 3 cos 2x. First function keep as it is. Differentiate log of 5x. Derivative of log of 5x is 1 by 5x into derivative of 5x is 5. Derivative of log x is 1 by x. Derivative of log of 5x 1 by 5x into differentiation of 5x, that is 5. Correct? Plus second function keep as it is. Log of 5x into derivative of 3 cos 2x. To differentiate 3 cos 2x, constant into variable. Constant into variable, constant keep as it is. Derivative of cos 2x minus sin 2x into derivative of 2x2. Correct? So minus sin 2x into differentiation of 2x, which is 2. Here 5 cancels. Correct? So what is left? Dy by dx equal to, from this dy by dx is equal to this y you cross multiply. Y into what we get? 3 cos 2x divided by x. Correct? Plus into minus is minus. 3 into 2, 6. 6 into sin 2x into log 5x. Then substitute back for y finally. Y is 5x to the power 3 cos 2x. 5 cancels. 3 cos 2x divided by x. Plus into minus minus. 3 into 2, 6. 6 sin 2x into log of 5x. Substitute back for y finally. Y is 5x to the power of 3 cos 2x multiplied by 3 cos 2x divided by x minus 6 into sin 2x into log 5x. Hope you understand. Variable power variable is given. correct? Take log on both sides, bring the power down. Log x power y is y log x. This is first function, the second function. Derivative of log x is 1 by x. Derivative of log y with respect to x is 1 by y into derivative of y with respect to x, dy by dx. First function keep as it is. Derivative of log of 5x, 1 by 5x into differentiation of 5x. To differentiate 5x, 5 you keep as it is. Derivative of x1, 5 into 1, 5. Plus second function keep as it is. Differentiate 3 cos 2x. Derivative of 3 cos 2x is 3 into minus sine 2x into derivative of 2x2. Derivative of cos is minus sine, no? Minus sine 2x into differentiation of 2x, which is 2. 3 into 2, 6. Minus 6. Correct? This is cross multiplied. Here 5 got cancelled. 3 cos 2x divided by x. Plus into minus minus. 3 into 2, 6. The numbers gets multiplied. 6 into sine 2x log of 5x. Then finally substitute back for y to get the answer. Hope you understand this. Move on to the next one. Differentiate x power x square minus 3 plus x minus 3 to the power x for x greater than 3 with respect to x. Take the given function as y. Let y be equal to this. This is variable power variable. This is also variable power variable. So I'll use derivative of u power v formula. Instead of taking log for this and log for this separately and it becomes lengthy. No. So I'll use directly derivative of u power v. U power v into derivative of v log u. Correct? Let y be equal to this. Let y is equal to x power x square minus 3 plus x minus 3 to the power x square. Correct? Differentiate with respect to x on both sides. Differentiate with respect to x on both sides. What do you get? dy by dx is equal to d by dx of x power x square minus 3. X power x square minus 3 plus d by dx of x minus 3 to the power x square. This is u power v. Derivative of u power v means write the same thing. U power v into derivative of v log u. Bring the power down and write log x. This is equal to what? X power x square minus 3. Write the same thing into d by dx of what I should write? Bring the power down v log u, correct? Derivative of v log u means bring the power down and write into log x. X square minus 3 into log x plus derivative of x minus 3 power x square is x minus 3 to the power x square into d by dx of what? Bring the power down x square log x minus 3. Correct? X square into log of x minus 3. Understood? I'm using this formula. D by dx of u power v. Derivative of u power v is u power v into d by dx of v log u. Learn this formula properly and apply it. Correct? Write the same thing into d by dx of bring the power down x square minus 3 into log x. Write the same thing first into d by dx of bring the power down x square. Apply log for this and write log of x minus 3 using this. Understood? U power v. Same thing you write into d by dx of v log u. So here you apply the product rule. Here also I need to apply the product rule and get the answer. So what we get? This is equal to x power x square minus 3 into, here apply the product rule. First function keep as it is, differentiate the second function, plus second function keep as it is, differentiate the first function. X square minus 3 into derivative of log x. Derivative of log x is 1 by x plus log x into derivative of x square minus 3, that is 2x. First function you write as it is. Differentiate log x 1 by x plus second function keep as it is. Derivative of x square minus 3 is 2x. Correct? First function keep as it is. Derivative of log x 1 by x. Plus second function keep as it is. Derivative of x square minus 3 is 2x. Plus second term here, x minus 3 to the power x square into. Here also I need to apply the product rule. First function keep as it is. Derivative of log x minus 3 is 1 by x minus 3 into derivative of x minus 3 is 1 plus log x minus 3 into derivative of x square is 2x. Hope you understand. Correct? First function keep as it is. Derivative of log x 1 by x plus second function keep as it is. Derivative of x square minus 3 is 2x plus this is kept as it is. Apply the product rule here. X square into derivative of log x minus 3 is 1 by x minus 3 into derivative of x minus 3 is 1 plus log x minus 3 into derivative of x square is 2x. Can simplify this one more step or keep as it is. Over. This much is enough. If you want, you can write in the proper order, that is x power x square minus 3 plus x square minus 3 divided by x plus what we have is 2x into log x, 2x into log x plus this is x minus 3 to the power x square, x minus 3 power x square into x square divided by x minus 3, correct, plus what we have is 2x into log of x minus 3, 2x into log of x minus 3. Hope you understand. Correct? This into 1 by x is written as x square minus 3 by x plus 2x into log x I wrote plus x square by x minus 3 plus 2x into log x minus 3. This is the answer. Hope you understand. All the questions from miscellaneous exercise I am working out. I finished questions on logarithmic differentiation. Next we got parametric differentiation and second order derivatives. Correct? Parametric differentiation. Take the first function as u. They asked to differentiate the first function with respect to another function. Take the first function as u, second function as v. Take u equal to sine square x and v equal to e power cos x. Take u equal to sine square x. Take u is equal to sine square x and v is equal to e power cos x. Take the first function as u. Take the second function as v. Find du by dx, dv by dx. Then find du by dv. It's like differentiating one function with respect to another function. Differentiating the one function with respect to another function. Take the first function as u. Second function as v. Sine square x means sine x the whole square. Correct? Sine square x is what? Sine x the whole square. Differentiate this with respect to x. Du by dx. Differentiate with respect to x. What we get? Du by dx. Du by dx is equal to. It is of the type x square. What is derivative of x square? Derivative of x square is 2x. Derivative of sin x the whole square is 2 sin x into derivative of sin x cos x. So 2 sin x cos x you get. 2 sin x into derivative of sin x is cos x. Of course, I can write it as sin 2x. I won't write it because I can cancel it later. I am finding derivative of u with respect to v. Here v is equal to e power cos x. Differentiate with respect to x. Differentiate with respect to x. What we get? dv by dx. dv by dx. Derivative of e power x is e power x. Derivative of e power cos x is e power cos x into derivative of cos x minus sin x. Correct? E power cos x into derivative of cos x is minus sin x. Now find du by dv. Want to find derivative of the first function with respect to second function. First function is taken as u. Second function is taken as v. So finding derivative of u with respect to v means du by dv. Want to find du by dv. Du by dv is equal to du by dx by dv by dx. Du by dx divided by dv by dx. du by dx is what? We got 2 sin x cos x. 2 sin x cos x. dv by dx. dv by dx is minus e power cos x into sin x. Correct? Derivative of e power x is e power x, but this is not x. So further differentiate cos x, we get minus sin x. Take the ratio of one by the other. Du by dx by dv by dx is du by dv, which is derivative of u with respect to v. So here sin x is going to cancel. So what I get is minus 2 cos x. This minus is taken to numerator. Minus 2 cos x divided by e power cos x. Correct? Sin x got cancelled. Minus 2 cos x divided by e power cos x. Or else you can take e power cos x to numerator, becomes e power minus cos x. So what I'm going to get is minus 2 cos x into e power minus cos x. Hope you understand. Derivative of x square. Derivative of x square is 2x. 2 sin x into derivative of sin x cos x. Of course, I can write this as sin x. I didn't write because I wanted to cancel some common terms. Derivative of e power x is e power x. Likewise, derivative of e power cos x is e power cos x into derivative of cos x minus sin x. Take the ratio du by dx by dv by dx. Sin x is going to cancel. So 2 cos x by minus e power cos x. Minus you take it to numerator. E power cos x is taken to numerator, becomes e power minus cos x. So finally we get minus 2 cos x by e into e power minus cos x, or minus 2 cos x divided by e power cos x. You can keep in this form or in this form, any form. Move on to the next one. For a positive constant a, find dy by dx given y is equal to a power t plus 1 by t and x equal to t plus 1 by t power a. Find out dy by dt. The parameter is t here. Parameter can be t or theta. If it is t, you find out dy by dt, dx by dt, then find dy by dx. If the parameter is theta, then find dy by d theta, dx by d theta, then find dy by dx, depending upon the parameter. Parameter means the third variable. X and y are the two variables. The third variable is t. That's called as parameter. X is a function of t, y is a function of t. So here a is a constant, correct? Positive constant they told. Constant power variable. If it is constant power variable, you apply the formula derivative of a power x. Derivative of a power x is a power x into log a. Correct? Here this is variable power constant. Variable power constant means x power a or x power n. Derivative of x power n into x power n minus 1. Again I repeat, if it is constant power variable, apply the formula derivative of a power x. What is derivative of a power x? A power x into log a. That formula should be applied here. This is variable power constant. If it is variable power constant, apply x power a formula or x power n formula. Derivative of x power a and x power n are almost same. Only the names are different. Correct? Derivative of x power n is what? N into x power n minus 1. Likewise, derivative of x power a is a into x power a minus 1. So dy by dt here. dy by dt. dy by dt is equal to, this is a power x. What is derivative of a power x? A power x into log a. So a power t plus 1 by t. A power t plus 1 by t into log a into derivative of t plus 1 by t. Derivative of t with respect to t is 1. Derivative of 1 by t is minus 1 by t square. Further, I should differentiate the power because that is not x. Derivative of a power x is a power x log a. But the power is not x, it's something else. So further, I need to differentiate this. Derivative of t with respect to t is 1. Derivative of 1 by t is minus 1 by t square. Coming to this, dx by dt. Dx by dt is equal to derivative of t plus 1 by t power a. It is like x power a. Derivative of x power a is a into x power a minus 1. So this becomes a into t plus 1 by t to the power a minus 1 into derivative of t plus 1 by t. Further differentiate. Derivative of t with respect to t is 1. Derivative of 1 by t is minus 1 by t square. Now finally I can find out dy by dx. Therefore dy by dx equal to dy by dx is equal to dy by dt divided by dx by dt. dy by dt divided by dx by dt. dy by dt is here, correct? A power t plus 1 by t log a power t plus 1 by t into log a into 1 minus 1 by t square. dx by dt is here, a into t plus 1 by t to the power a minus 1, correct, into 1 minus 1 by t square. Here 1 minus 1 by t square is going to cancel. So what is left is a power t plus 1 by t, a power t plus 1 by t into log a, correct, divided by a into t plus 1 by t to the power a minus 1. Hope you understand. dy by dx is dy by dt by dx by dt. 1 minus 1 by t square is going to cancel. A power t plus 1 by t into log a divided by a into t plus 1 by t power a minus 1. The formulas used here are d by dx of a power x. d by dx of a power x is a power x into log a. And also I use derivative of x power a. Derivative of x power a is a into x power a minus 1. Derivative of x power is a into x power a minus 1. These two formulas are used in this problem. Parametric difference. Hope you understand. Move on to the next one. Given y is equal to 12 into 1 minus cos t, x equal to 10 into t minus sin t. Want to find dy by dx where t lies between minus pi by 2 and pi by 2. Find out dy by dt, dx by dt, x is function of t, y is function of t, so parameter is t. Want to find dy by dx, parametric differentiation. So dy by dt is equal to constant into variable, constant keep as it is. Differentiate the terms inside the bracket. Derivative of 1 is 0. Derivative of minus cos t is plus sin t. Dx by dt from this. Dx by dt is equal to dx by dt is constant into variable, constant keep as it is. Differentiate the variable. Derivative of t with respect to t is 1. Derivative of sin t is cos t. Now find out dy by dx. dy by dx is equal to dy by dt divided by dx by dt. dy by dt by dx by dt. What is dy by dt? 12 sin t. Dx by dt is 10 into 1 minus cos t. dy by dt is here 12 into sin t divided by dx by dt is 10 into 1 minus cos t. 12 by 10 is 6 by 5. Correct? 12 by 10. 2 5s are 2 6 are cancels. Sin t you can write the formula. 2 sin t by 2 cos t by 2. Half angle formula. 2 sin t by 2 cos t by 2. Denominator is 1 minus cos t, which is 2 sin square t by 2. 2 sin square t by 2 using half angle formula for 1 minus cos t and sin t. 2 cancels. 1 sin will cancel. Sin square means sin into sin. 1 sin will cancel. 1 sin remains. Cos by sin is cot. So what you get is 6 by 5 into cot t by 2. Correct? 12 by 10 simplifies to 6 by 5. Sin t, applying half angle formula, 2 sin t by 2 cos t by 2. 1 minus cos t, 2 sin square t by 2. 2 cancels. Sin square means sin into sin. 1 sin got cancelled. 1 sin remains here. Cos by sin is cot. 6 by 5 cot t by 2. 3 problems were there on parametric differentiation on miscellaneous exercise of NCERT exercise. Chapter 5. Continuity and differentiability. Second order derivatives. Y is given as e power a cos inverse x. X lies between -1 plus 1. I think in the textbook they given the closed interval. I taken open interval. Differentiability we speak at open interval, in the open interval. Because if you include +1 and -1, denominator will become 0 when you differentiate. After differentiating and putting x equal to 1, derivative does not exist. So I taken open interval. I made a correction and taken. Okay. Want to show that 1 minus x square into second derivative minus x into first derivative minus a square y equal to 0. Okay. Question from the miscellaneous exercise on second order derivatives or successive differentiation also we can call. A is a constant here. Given y is equal to e power a cos inverse x. Given y is equal to e power a cos inverse x. Differentiate with respect to x on both sides. Differentiating with respect to x on both sides. Differentiating with respect to x on both sides. What we get? Dy by dx. Dy by dx is equal to, here derivative of e power x. What is derivative of e power x? E power x. Derivative of e power a cos inverse x is e power a cos inverse x into derivative of a cos inverse x. A into derivative of cos inverse x minus 1 by root of 1 minus x square. Cross multiply this. Cross multiply. Okay. Root of 1 minus x square, bring it to left hand side. Root of 1 minus x square into dy by dx is equal to what we have? Minus a into minus 1 is minus a into e power a cos inverse x. We know that e power a cos inverse x is y, no? Substitute back. So this becomes equal to minus a into y. Because y is equal to e power a cos inverse x. Y is equal to e power a cos inverse x. Now do squaring on both sides. Directly also I can differentiate at this stage. I need to differentiate 2 times because there is second order derivative d square y by dx square. Correct? I can differentiate directly at this stage for the second time. I will do squaring on both sides and then differentiate. That becomes easier. Okay? Squaring on both sides. Squaring on both sides. What I get? Squaring on both sides. That becomes easy for us. So I am following these steps. Squaring on both sides. What we get? Root of 1 minus x square will be 1 minus x square into dy by dx the whole square. Dy by dx the whole square is equal to minus a square is same as a square into y square. Squaring on both sides. Square this, square this. Hope you understand. First, what is given? Y equal to e power a cos inverse x. Differentiate with respect to x on both sides. Dy by dx equal to derivative of e power x is e power x. But this is not x. So further differentiate. Derivative of a cos inverse x is a into derivative of cos inverse x minus 1 by root of 1 minus x square. Cross multiply it. Okay, then use the given equation once again. E power a cos inverse x is y, correct? Y. So y is nothing but e power a cos inverse x. Do squaring on both sides. Now differentiate with respect to x once again on both sides. Differentiating with respect to x on both sides. Differentiating with respect to x again on both sides. Here I should apply the product rule because it is multiplication of 2 functions. It is product of 2 functions. I need to apply the product rule. Right hand side, constant into variable. A is a constant, so a square is constant. Constant into variable. Constant keep as it is. Differentiate y square. Derivative of y square is 2y into derivative of y with respect to x, dy by dx. Here I need to apply the product rule because it is product of 2 functions. First function keep as it is. First function keep as it is. Differentiate the second function dy by dx the whole square. Derivative of dy by dx the whole square is 2 dy by dx into derivative of dy by dx is d square y by dx square. Differentiate dy by dx the whole square as you differentiate x square. Derivative of x square is 2x. Likewise, derivative of dy by dx the whole square is 2 into dy by dx into derivative of dy by dx is d square y by dx square. Correct? Derivative of dy by dx whole square is 2 into dy by dx into derivative of dy by dx is d square y by dx square plus second function keep as it is dy by dx the whole square. Second function keep as it is. Differentiate the first function. Derivative of 1 minus x square is minus 2x. Correct? Minus 2x is equal to a square into derivative of y square is 2y dy by dx. 2y into dy by dx. Hope you understand. Correct? A square into 2y dy by dx. Now, you see everywhere 2 into dy by dx is present. So, you can divide the entire equation by 2 into dy by dx so that we get the answer. See, 2 into dy by dx is found here. 2 into dy by dx is found here. So, in these kind of problems, no, y equal to e power a cos inverse x or y equal to e power a sin inverse of x or sin of a sin inverse x or sin of a cos inverse x or cos of a cos inverse x or cos of a sin inverse x. In all these 6 problems, the method of finding the second order derivative or forming the differential equation, the steps I can tell you: differentiate, cross multiply, squaring on both sides, again differentiate, divide throughout by 2 into dy by dx. We'll get the answer. Formation of differential equation, these problems are called. Okay, divide throughout by 2 into dy by dx. 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 When you divide by 2 into dy by dx, it's going to cancel. What I'm going to get? 1 minus x square into d square y by dx square. 1 minus x square into d square y by dx square. Here I am dividing by 2 into dy by dx. So plus into minus is minus x into dy by dx. Dividing by 2 into dy by dx. Here also I'm dividing by 2 into dy by dx is equal to a square y. Correct? I am dividing the entire equation by 2 into dy by dx. I got the answer. Shift this a square y to left hand side. Minus a square y equal to 0. Hence proved. 1 minus x square into d square y by dx square minus x into dy by dx minus a square y equal to 0. This implies 1 minus x square into d square y by dx square minus x into dy by dx minus a square into y is equal to 0. Understood? Please make a note of this. Move on to the next one. Given x equal to a into cos t plus t sin t, y is equal to, you are missing that, y is equal to a into sin t minus t cos t. Find d square y by dx square. This is second order derivative on parametric differentiation. Parametric with second order, correct? Parametric equations are given. X is function of t, y is function of t. Find out dx by dt, dy by dt. Then you need to find the second order derivative, d square y by dx square. So dx by dt here, dx by dt is equal to constant into variable, constant keep as it is, Differentiate the terms inside the bracket. Derivative of cost is minus sin t. Derivative of cost is minus sin t. Here you need to apply the product rule because it is product of two functions. First into derivative of second plus second into derivative of first. First function is t, second function is sin t. First function keep as it is. Differentiate sin t. What do you get? Cos t. Plus second function keep as it is. Sin t into derivative of t is 1. Correct? First function keep as it is. Derivative of sin t is cos t. Plus second function keep as it is. Differentiate t, which is 1. So here sin t into 1, sin t, correct? So what I am going to get is a into minus sin t plus t cos t plus sin t. Correct? Sin t is going to cancel. So what I am going to get is a into t cos t. Same way find out dy by dt from here. Y is given as a into sin t minus t cos t. Dy by dt equal to dy by dt is equal to constant into variable. Constant keep as it is. A is constant, keep as it is. Differentiate the terms inside the bracket. Derivative of sin t is cos t. Correct? Cos t. Derivative of sin t is cos t. To differentiate t cos t, apply the product rule. Product of two functions. So apply the product rule. Minus sign is it. Take care. Minus of. Open a bracket. Because minus sign comes when you differentiate this by using product rule, I get two terms there. So minus of, I get two terms. Minus sign is you put a bracket there. So first into derivative of second. Correct? First function keep as it is. Derivative of cos t is minus sin t. T into minus sin t plus second function cos t into derivative of t is 1. Correct? Derivative of sin is cos. Here apply the product rule. First function keep as it is. Derivative of cos t is minus sin t plus second function keep as it is. Derivative of t with respect to t is 1. First into derivative of second plus second into derivative of first. First function keep as it is. Derivative of cos t minus sin t plus second function write as it is. Differentiate t with respect to t, which is 1. So what I am going to get is a into cos t minus into minus becomes plus t sin t. Correct? Minus into plus is minus cos t. So cos t is going to cancel. What we get is a t sin t. So we got dy by dt and dx by dt. Now we can find dy by dx. Therefore, dy by dx equal to dy by dx is equal to dy by dt divided by dx by dt. Dy by dt is at sin t. Dx by dt is at cos t. At is going to cancel. Sin t by cos t is tan t. Dy by dx is tan t. Need to find d square y by dx square, the second order derivative. D square y by dx square. D square y by dx square is equal to d by dx of dy by dx. D by dx of dy by dx. That is equal to d by dx of, what is dy by dx? We got tan t. You're differentiating tan t with respect to x. Take care of this. Very important step. Don't do a mistake here. Correct? Don't make mistake here. Derivative of tan x with respect to x is secant square x. Derivative of tan t with respect to t is secant square t. But here differentiating tan t with respect to x. The variables are not same here. Correct? Suppose I'll write here d by dx of tan x is secant square x. You can note down all these things. You'll make mistake in the exam. Derivative of tan x. Don't do mistake like this. Okay? Derivative of tan x is secant square x. I'm differentiating tan x with respect to x. The variables are same there. correct? If you're differentiating tan t with respect to t, d by dt of tan t is equal to how much? Secant square t. Derivative of tan t with respect to t, secant square t. You are differentiating tan t with respect to x. Hope you understand difference between these two and this. Here the variables are same. X with respect to x, t with respect to t. Here the variables are different. You are differentiating tan t with respect to x. So secant square t into derivative of t with respect to x, dt by dx. Further, I need to differentiate the variable t with respect to x, follows by chain rule. Correct? Derivative of tan t with respect to x is derivative of tan t is secant square t into further differentiate t with respect to x, that is dt by dx. dt by dx is the reciprocal of dx by dt. You know the first derivatives are always reciprocals. Dx by dt is at cos t. So dt by dx is reciprocal of this. Dx by dt and dt by dx are reciprocals. At cos t reciprocal is 1 by at cos t. Correct? This is equal to secant square t into dt by dx is 1 by at cos t. 1 by at cos t. So this is equal to 1 by at. 1 by cos is sec. Sec into secant square is secant cube t. So secant cube t divided by at. That's the answer. 1 by at into secant cube t. Or secant cube t divided by at I can write. That is the second order derivative for this. Important step is this. This is an important step from this step to this step. Very important step. Understood? Finding dx by dt, dy by dt, find dy by dx, then d square y by dx square. Second order derivative. Second order derivative is differentiating the first derivative. If you differentiate the first derivative with respect to x, what we get is second derivative. Dy by dx is tan t. So derivative of tan t with respect to x is secant square t into derivative of t with respect to x, dt by dx. dt by dx is reciprocal of this. Dx by dt is at cos t. Dt by dx is 1 by at cos t. And 1 by cos is sec. Secant square into sec becomes secant cube. Secant cube t divided by at. Or 1 by at into secant cube t. Move on to the next one. If x minus a the whole square plus y minus b the whole square equal to c square for some c greater than 0, prove that 1 plus dy by dx the whole square power 3 by 2 divided by d square y by dx square is a constant which is independent of a and b. Okay, so the equation of circle is this, correct? Having center at a comma b and radius is c. It's the equation of circle. Differentiate this with respect to x, find dy by dx, then go for second order derivative and show that this expression is a constant which is independent of a and b. Okay, so given equation is given x minus a the whole square plus y minus b the whole square is equal to c square. This is given to us. Differentiate with respect to x on both sides. Differentiate with respect to x on both sides. Derivative of x minus a the whole square is what? 2 times x minus a into derivative of x minus a, which is 1. Derivative of x1, derivative of a is 0. A, b, c are constants here, correct? Derivative of x square is 2x, no? Likewise, derivative of x minus a the whole square is 2 times x minus a, 2 times x minus a into derivative of x minus a, derivative of x 1, derivative of a 0, 1 minus 0, 1. Derivative of y minus b the whole square is what? 2 times y minus b into derivative of y minus b is dy by dx. Derivative of y minus b the whole square is 2 times y minus b into derivative of y minus b. Derivative of y is dy by dx. Derivative of b is 0. And derivative of c square is 0. Correct? Derivative of y minus b the whole square is 2 times y minus b into derivative of y minus b is dy by dx. Derivative of c square is 0. Now you can divide the entire equation by 2. 2 is common factor, correct? So from this divide by 2, I'll get x minus a into 1, x minus a is equal to, this will shift it to other side, you get minus of y minus b into dy by dx. Correct? This entire thing is taken to that side, divide by 2 also. Therefore dy by dx I'll get minus, shift that side, minus of x minus a by y minus b. From this I get dy by dx. dy by dx is equal to minus of x minus a divided by y minus b. Correct? dy by dx is minus of x minus a divided by y minus b. Now differentiate this again using quotient rule to find the second order derivative, d square y by dx square. Apply quotient rule for this. D square y by dx square. I'll write here because it's a lengthy problem. I need more space. I'll write d square y by dx square. Differentiate this with respect to x again. Differentiate this with respect to x again. So applying quotient rule, denominator square, y minus b the whole square, denominator square. In the numerator, I should start from denominator, right? Denominator keep as it is. Denominator keep as it is. Differentiate minus of x minus a, d by dx of minus of x minus a. Minus numerator into, numerator is minus of x minus a, minus of minus x minus a into d by dx of denominator, correct? Using quotient rule, d by dx of denominator is y minus b, correct? Denominator square. In the numerator, start from denominator into derivative of numerator, minus numerator into derivative of denominator. So this is equal to what? Y minus b into derivative of minus of x minus a is minus 1, correct? Derivative of minus x is minus 1. Derivative of plus a is 0. Minus into minus will become plus. So what I am going to get? X minus a into derivative of y minus b. Derivative of y is dy by dx. Derivative of b is 0. So I am getting dy by dx here. dy by dx. Whole thing is divided by y minus b the whole square. And substitute for dy by dx from the earlier step. From the earlier step, we got dy by dx like this, no? Minus of x minus a by y minus, that I am going to substitute here. So this is minus of y minus b, minus 1 to this, minus of y minus b plus x minus a into dy by dx is what? Minus of x minus a by y minus b, minus of x minus a divided by y minus b, divided by y minus b the whole square, correct? Here you can take common denominator. This is by 1. So I'll take y minus b as common denominator there. So this will be y minus b, the common denominator, correct? This y minus b gets multiplied to this because 1 I have to multiply by y minus b to get this. That y minus b into y minus b becomes y minus b the whole square. So minus of y minus b the whole square. Here plus into minus is minus. This I have to multiply by 1 to get this. That 1 into x minus a, that is x minus a the whole square. This entire thing is divided by y minus b the whole square. Y minus b the whole square. Correct? Here you can take minus sign common. Correct? If you take minus sign common, I get the equation of circle only. X minus a the whole square plus y minus b the whole square. And this y minus b comes to denominator. Gets multiplied to this y minus b, because dividing by number means multiply by the reciprocal. This y minus b comes to denominator, becomes y minus b into y minus b the whole square, which is y minus b the whole cube. Here you can take minus sign common. Correct? So if you take minus sign common, it will be minus of what we get? X minus a the whole square plus y minus b the whole square, correct? Divided by y minus b the whole cube. Y minus b the whole cube. What is x minus a the whole square plus y minus b the whole square? C square. So this becomes minus c square, correct? Minus c square divided by y minus b the whole cube. So we got the second order derivative, d square y by dx square. Now I need to consider this expression, 1 plus dy by dx the whole square power 3 by 2 by d square y by dx square. Therefore consider this. Consider what? 1 plus dy by dx the whole square, 1 plus dy by dx the whole square divided by d square y by dx square to the power 3 by 2 for this. Numerator is raised to the power 3 by 2. Correct? This is equal to 1 plus, what is it? Dy by dx the whole square. Square this and write. Minus square is plus. Minus square will be plus x minus a the whole square by y minus b the whole square. Correct? X minus a the whole square plus y minus b the whole square. This entire thing to the power 3 by 2. Divided by d square y by dx square, I got minus c square by y minus b the whole cube. Minus c square divided by y minus b the whole cube. And here you can take LCM, y minus b the whole square. Therefore, if you take LCM as y minus b the whole square, I get y minus b the whole square plus x minus a the whole square, correct? So I'll write here the remaining part of this. Let's see, equal to what I'm going to get, y minus b the whole square, y minus b the whole square plus x minus a the whole square, correct, to the power 3 by 2 z, and denominator is y minus b the whole square power 3 by 2, correct, y minus b the whole square to the power 3 by 2, correct, divided by minus c square divided by y minus b the whole cube. Here the powers gets multiplied. 2 into 3 by 2 becomes 3. So this is y minus b the whole cube. This is also y minus b the whole cube. These two will cancel. This entire thing will cancel. And what we have, x minus a the whole square plus y minus b the whole square is c square according to this. So this becomes c square power 3 by 2. So what I am going to get, c square to the power 3 by 2 divided by minus c square. C square power 3 by 2 is c cube, correct? C cube divided by minus c square, which simplifies to minus c, correct? C square power 3 by 2. Terms inside this bracket is c square according to this equation or this equation, correct? C square power 3 by 2 will be c cube. C square power 3 by 2. Powers gets multiplied. 2 into 3 by 2 is 3. So c cube by minus c square. C square cancels. We get minus c. So this expression what we got? 1 plus dy by dx the whole square power 3 by 2 by d square y by dx square equal to minus c. So which is a constant independent of a and b. Minus c is a constant which is independent of a and b. This represents the, if you take modulus for this, it represents the radius of the circle. In fact, mod of 1 plus dy by dx the whole square power 3 by 2 divided by d square y by dx square is the radius of the circle. Okay. So, hence proved. Dy by dx we find out. Then again differentiate this using quotient rule we are using quotient rule and making use of dy by dx. Here while applying the quotient rule I get dy by dx. Again substitute back dy by dx from the earlier step and take LCM and go on simplify. After this step I come till here and consider the expression given in the question. 1 plus dy by dx whole square power 3 by 2 by d square y by dx square. We got the answer as minus c, which is a constant independent of a and b. Hence proved. Move on to the next one. F of x equal to mod x cube. Show that f double dash of x exists for all real x and find it. So mod x cube is given. So we can apply the definition of modulus function here. F of x is given to be equal to mod x cube. This is equal to mod x will be equal to x if x is greater than or equal to 0. Mod x is x if x is greater than or equal to 0. Mod x is minus x cube if x is less than 0, correct? By definition of modulus function. So x cube I can keep as it is. And minus x the whole cube is same as minus x cube. Minus cube is minus. So this becomes minus x cube. This is for x greater than or equal to 0. And this is for x less than 0. Find out. Of course, the function is continuous everywhere. For x greater than 0, x cube polynomial function is continuous everywhere. For x less than 0, the function is minus x cube. It's a polynomial function, continuous everywhere. Even at 0, it is continuous. You can find out the left hand limit. Left hand limit for x less than 0, minus 0 cube, minus 0, that is same as 0. Right hand limit for x greater than 0, 0 cube 0. F of 0 also 0. The function is continuous. So I can differentiate this. F dash of x. Find out the derivative. The function is continuous. So differentiate f dash of x, what do you get? 3x square. This is for x greater than or equal to 0. X greater than or equal to 0. Derivative of minus x cube is minus 3x square. This is for x less than 0. F dash of x. The function is differentiable or not, you can find out at x equal to 0. At x equal to 0, function is not differentiable, correct? Because f dash of 0 plus, no, it's differentiable, right? It's differentiable, f dash of x. F dash of x exists. F dash of 0 plus 3 into 0 square, 0. F dash of 0 minus 3 into 0 square, 0 only. F dash of 0 exists. Even f double dash of x, f double at x equal to 0, the function is differentiable, correct? F double dash of x we'll find out. F double dash of x. Further differentiate this. F double dash of x. Derivative of 3x square is 6x. This is for x greater than or equal to 0. X greater than or equal to 0. Derivative of minus 3x square is minus 6x. This is for x less than 0. Correct? Even at 0, the function is differentiable. If you find out, you have double dash of 0 plus. You have double dash of 0 plus will be. 0 plus means greater than 0. Greater than 0, 6 into 0 is 0. You have double dash of 0 minus. You have double dash of 0 minus. 0 minus means x less than 0. X less than 0. Derivative is minus 6x. Minus 6 into 0, 0. The function is differentiable even at x equal to 0. For all x greater than or equal to 0, second derivative is 6x. For all x less than 0, second derivative is minus 6x. And x equal to 0, the function is differentiable. You have double dash of 0 is equal to 0. The function is differentiable. And the derivative is shown here. Correct? For at x equal to 0, second derivative is 0. For x greater than or equal to 0, you have double dash of x is 6x. For x less than 0, derivative is minus 6x. Hence, I have shown the second derivative. It exists. Show that f double dash of x exists for all real x and find it. Of course, it exists for all real x. For positive values, it exists. For negative value, it exists. For 0 also, it is 0. So, derivative, second derivative exists for every real x and it is shown here. Find it as, I have found it here, second derivative for different conditions. For x greater than or equal to 0, second derivative is 6x. For x less than 0, second derivative is minus 6x. At x equal to 0, it is 0. Move on to the next one. Differentiation of a determinant. I think this is the last question. We need to show this. Y is given as determinant of. First row is f of x, g of x, h of x. Second row and third row are constants L, M, N and A, B, C respectively. Want to prove that dy by dx equal to. First row determinant is f dash, g dash, h dash. And second row, third row kept as it is. So what we can do is first you expand this determinant and then differentiate. And dy by dx already given a differentiate. Show that both are same. Given y is equal to determinant of f of x, g of x, h of x, LMN, second row. Third row is A, B, C. Correct? This question was asked in CET exam, so better to remember how to differentiate a determinant. All those things I'll be doing in synopsis, okay? Synopsis of continuity and differentiability for various competitive exams. KCET, NDA, JEE and any other competitive exams will be done in coming days. So, expanding this determinant here along the first row. F of x into, expanding it, leaving first column, first row. MC minus BN, correct? MC minus BN minus g of x into, leaving second column, first row. What do you get? LC minus NA. LC minus NA or AN plus H of X into, leaving the third column first row, what do you get? LB minus AM, LB minus AM, LB minus AM. LB minus AM. Now MC minus BN, the terms inside the bracket is constant because ABC and LMN are constants. No, constant into variable. How to differentiate? You know, constant keep as it is. Differentiate the variable. So dy by dx is equal to what we have, MC minus BN, constant keep as it is. Differentiate f of x, that is f dash of x, minus constant keep as it is LC minus NA into derivative of g of x is g dash of x plus LB minus AM, into derivative of h of x is h dash of x. Call this equation 1. dy by dx I got. Differentiating this determinant. Expanding the determinant along the first row, plus minus plus along the first row. We know how to expand the determinant, then differentiate. Constant into variable. Constant keep as it is, differentiate the variable. We get like this. And dy by dx is given here, no? I'll expand that determinant. So dy by dx, according to the question, dy by dx is given to be equal to determinant of f dash of x, g dash of x, h dash of x. Here what we have, L, M, N, A, B, C. Expand this. Expanding this determinant along the first row, what you get? F dash of x into, leaving the first column first row, MC minus BN, crisscross, applesauce, multiply, MC minus BN minus G dash of x into, leaving the second column first row, what do you get? LC minus AN or NA, LC minus NA plus H dash of x, into, leaving third column first row, what do you get? LB minus AM, LB minus AM. This is called equation 2. So compare equations 1 and 2. This is equation 1, dy by dx here. MC minus Bn into f dash of x minus LC minus Na into g dash of x plus LB minus AM into h dash of x. From 1 and 2, both are same, right? From equations 1 and 2, I can conclude that both are same. They are hence proved. From 1 and 2, I get this dy by dx is proved. Dy by dx equal to, we get the answer. Hence proved. You can complete the sentence. Compare these two. Dy by dx is like this we got, and dy by dx like this. So dy by dx will be equal to determinant of this. Hence proved. Okay. With this, we completed all the questions of the NCERT miscellaneous exercise of chapter 5. Okay. NCERT miscellaneous exercise of chapter 5, continuity and differentiability, has been completed, completely solved. Various problems were there on continuity and differentiability, derivatives of composite function, derivatives of inverse trigonometry functions, implicit function differentiation, logarithmic differentiation, parametric differentiation, second order derivatives, and also how to differentiate a determinant. These are the multiple concepts covered in this miscellaneous exercise. I'll be uploading more and more videos in the coming days. The NCERT also I'll be focusing on. NDA exams are coming shortly on 14th of September, Sunday, correct? Second exam of this year coming. So I'll be discussing NDA paper also in the coming days. Okay, of 2025 April exam, I'll discuss the paper. 120 questions will be there in the NDA, and more of NDA papers will be uploaded. More videos will be uploaded on NDA papers also. NDA videos also I'll be doing. and JEE also I'll be focusing more, JEE main and also KCET also, all the previous year questions and the synopsis. I've got a powerful synopsis. So already I've done limits chapter synopsis and more synopsis I'll be doing. All chapters I'll be covering, maybe inverse trigonometry functions, continuity and differentiability, trigonometry, complex numbers, all one by one I'll touch. I'll complete. Maximum videos will be uploaded in the coming days. With this, we'll conclude. Thank you.